All right, everyone. So thank you for joining into the AWS Certified Solutions Architect Associate course. This is the 2020 curriculum, or the SAA's C02 curriculum. Although it is mentioned as C02, which is more or less an exam denotion or an exam curriculum denotion, this course is not an exam course, all right? Although once you do this course, you should be able to perfectly ace your exams, even do better than someone who just takes a exam course. But this is not an exam course that you're joining. My whole idea with this course is to make sure that I give you in-depth knowledge and understanding, so that you don't have to memorize things. That when you look at certain scenarios, you can easily understand what's going on. So whether it is your exams or your future interviews, this course should help you do much better in those scenarios than just me telling you that if this question comes in the exam, answer it like this and things like that. However, we will be talking about some exam strategies towards the end of our sessions, so that if you are going to do the exam, you know how that it's going to work. So let me give a quick introduction. Some of you already know me, but my name is Faisal Khan. I'm the founder and CEO of a company called Ecom India Cloud IT. We are basically a managed cloud solutions provider. We are at the moment solely focused on AWS, while we have some business with the other cloud as well, like Azure and Google. Our core focus is AWS. So we do a lot of digital transformation into the AWS cloud, where we help organizations move their entire IT infrastructure onto the cloud platform, and specifically AWS. So all of the training that I'm going to give you is going to be from that experience of myself and my team learning how to do these things on AWS. So it's not just a random theory session. I want to make sure that you understand what's happening in the backend, and hopefully that should help you with you doing your migrations or interviews or anything like that. So in this transformation stage, we of course do the architecting side of the cloud, where we decide how to build something on the cloud. Then obviously the implementation, which involves processes like DevOps, security, which is SecOps and things like that, or data analytics and all of those things. And then post that, you have the monitoring, which is basically like your production support kind of thing. So overall, I come with about approximately 16 years of experience in IT infrastructure management. Now, this is a keyword, IT infrastructure management, because as you will discover in this course, that cloud is not something totally different. It is basically IT infrastructure, right? So if you're already coming from an infrastructure background, or if you already have some fairly good understanding of IT infrastructure, learning the cloud is going to be very easy for you, because of the fact that it's not some new technology. It's basically a different way of implementing IT infrastructure, right? That's all what the cloud is. So all of this experience comes from organizations like JP Morgan Chase, Bank of America, Dell, ITC, etc. All right, so let's see what we're going to do today. Today, let's first talk about what this course is about, how this is going to help you, and let's discuss a little bit about how this course is structured, the duration and all of that. And there are a few do's and don'ts that I just want to mention briefly. And we'll look at the topics that we will be discussing in the entire course. And we'll talk about some prerequisites that is kind of required for this course. All right, so what's this course about? We're going to focus on cloud architecture and possibly administering a little bit of services within AWS, but the focus is going to be around architecting solutions on the cloud. Now, we are going to go a little bit in terms of hands-on, which you normally don't need to do as an architect. This is just to make sure that you understand how the underlying technology works. Also, you have to understand, when we talk about architecture, you're not going to be coding anything on AWS. You're not going to be doing actually any hands-on on AWS in your day-to-day job, because you need to know how all of these pieces within AWS works, how you can put them together, and how you can build a solution, right? That's going to be your main job from an architect perspective. So we're going to try to focus on that. So we're not going to do any coding or anything like that. So if you thought you had to code or anything, don't worry, we're not going to do that. But still, we are going to go a little bit deep in terms of a little bit hands-on on the core services like EC2, S3, and auto scaling and all of that, so that you know how this works, so that when you build a solution, you understand what the limitations are over there, and not just tell someone go build this, right? So that's going to be our focus. Like I've already mentioned, if you already know what IT infrastructure is, this is going to be very easy for you. If not, don't worry, we are starting from scratch. For those of you who have already seen my videos, I hope you understand that I try to explain it in a way that anybody can understand. All right. So no worries, but if you're already good over there, then you don't need to worry. All right, so we are going to also cover the sysops and developer tools, or the DevOps tools per se, on AWS, but we're going to cover them from an architect perspective. So like I mentioned, you're not actually going to be developing or doing system administration on AWS when you're an architect, but you still need to know what those tools are, and you need to know, where you can implement those tools, or how you're going to build something on AWS with those tools. So that's what we're going to learn. Like I've already mentioned, we are going to focus on knowledge and hands-on, rather than just remembering things and trying to, just keep certain points in our mind, like you're going to write an exam or something like that. Once you have the knowledge, everything becomes natural to you. That's the focus of this. Now, this also kind of makes you a thorough cloud professional, in the sense that once you learn AWS and once you learn how the AWS cloud works, almost every other cloud becomes very, very easy for you, because of the fact that if you look across the cloud providers, about 60 to 70%, I would say over 70% of the architectures, about 70% of the services are almost the same. So you will find similar services across AWS, across Google, across Azure, right? The only difference is the way those things are implemented. So once you learn AWS, you're almost 70% know how Azure works. You almost 70% know how Google works, right? You just need to go and kind of see how they have set it up, right? So it kind of, makes you a thorough cloud professional. So make sure you use this opportunity to not just learn AWS, and after this, just go and see the other cloud platforms, and it'll be very easy for you to pick those up as well. This also opens up you to other specializations on the cloud, because if you know, within AWS, there are several routes you can take. You can take the architect route, you can take the DevOps route, and also there are additional specializations that AWS has recently added. For example, specialization in security, specialization in data analytics, specialization in networking, right? And specialization in AI and ML. So there are a lot of specializations within the AWS cloud that you can take. So if you think you're not this person who's into general architecture, once you know how the architecture works, you can go ahead and specialize on those certain categories within AWS, which will give you kind of a niche skill set. So if you want, have a look at that, and I will talk about that in detail probably in our last session, where we talk about what are your different exam options and career paths and all of that. All right, let's kind of look at the topics that we're going to cover. Now, these are the core topics, which means the main topics. Now, under each of this topic, we have several subtopics that we're going to talk about, right? So don't just think that we are only going to cover each individual service that you're seeing here. I have split this up into the number of days that we're going to cover this. Now, most of this is going to happen exactly how this is, but sometimes what happens is, depending on the batch, as I'm teaching this, depending on the batch, sometimes I might have to bring a topic forward, or I might have to push a topic later on. So, but we will cover all of this, all right? So today we are going to start off with what the concept of cloud computing is, and we're going to get a peek into what is AWS and why they have become what they have become today, and what are the services that they're offering, right? That's what we're going to cover today. Tomorrow we will look at EC2 instances, which is the core of AWS. That's how everything, kind of started for AWS. Of course, that was not the first service, but that's what kind of made them famous. Now, of course, within EC2s, there are so many subtopics. Like we talk about what are AMIs, we talk about keys that you're going to use, instance metadata. So each of this will have several subtopics below it. I am definitely, this one screen is not enough to display all of the topics. All right. Then we have EBS volumes the day after that, which is your hard disks and things like that. Then the day after that, we're going to talk about load balancers, all of the different types of load balancers, how you can balance out your environment when traffic comes in. We will briefly mention about autoscaling, but we will talk about autoscaling in more detail later on. On day 5, which is the end of this week, we will be talking about the storage service on AWS, more or less like object storage, which is S3 and Glacier, which are the object storage services. On day 6, which is next week, we'll be talking about additional storage services like Elastic File Store or Elastic File System, FSX for Windows, and the storage gateway, and all of the Snow devices like Snowball and all of that. And on day 7, we're going to talk about the networking aspect within AWS, which is basically your VPC. So we'll go into the networking concept a little bit. On day 8, after that, we'll talk about DNS, how domain name systems work on AWS. Now, you will need a domain name while we do this session. I'll talk about that, how to get that and all of that. On day 9, we're going to look at security. So we're going to see how you can secure things within AWS, how you can control access to services in AWS using IAM. We'll also briefly talk about how encryption management works on AWS, how you can secure your data and things like that. On day 10, we're going to do the day 1 of databases. So database is actually split into 2 days. You can see database 1 and database 2 on day 10 and 11. We'll try to discuss the relational database services and Aurora on the first day. On the next day, we'll try to discuss DynamoDB and Elasticache. Post that, we'll talk about a service called Elastic Beanstalk. We probably will not take the entire day to do that. We'll fit in some other topics as well because it's not that big of a topic. Post that, we will talk about how you can have a kind of a global network, right? CDN, so to speak. So we'll talk about CloudFront, Global Accelerator, etc. Post that, we'll talk about a monitoring service called CloudWatch. And we'll also talk about something like CloudTrail and all of that on the same day, where we see how you can monitor what's happening within your environment. And that will be the day we talk about autoscaling as well, because CloudWatch and autoscaling kind of go hand in hand. Without one, the other is not going to really work. We'll have CloudFormation and command line interface. So we'll see how we can automate deployments using templates that we can code, or more or less like infrastructure as code on day 15. On day 16, we're going to talk about some additional AWS services like container services, Kubernetes, Lambda, API gateway, etc. Day after that, we're going to talk about some queuing services, streaming services like Kinesis, notification services, SNS, email services, SES, and some MQ services. Day 18, I have left for some additional AWS services, which are kind of small enough that you don't need an entire day to talk about them. So we'll put all of that on day 18. On day 19, we're going to use everything that we have learned all the way from day 1 up to day 18, and we're going to build a project, right? And this is going to be a multi-tiered high availability project. So you're going to basically build a live solution, which you can test yourself, and you can actually have real customers if you wish to going to that site. And we'll be building it as a multi-tier, which means there will be high availability, there will be failover available, everything will be there. So you will, at the end of this session, be able to build your own environment within AWS after we go through all of this. Post that, on our last day, we will talk about how you can do billing on AWS. There is something called organizations on AWS, where you have multiple organizations that come under one section, right? So we'll talk about how that works. And also we'll talk about things like your exam, if you wish to go take it. And we'll talk about the different career paths and everything that you have. So these are the topics that we're going to cover over the next 20 days, guys. I would like to take a moment here and pause and ask if you have any questions on any of these topics, or if there's something else that you thought was covered and not here. Anybody? All right. I guess that's a no. All right. One thing I would like to add, as we are going through these sessions, guys, I definitely want it to be interactive. That is the only reason my sessions stay interesting, is because of the interactivity, right? And of course, you are paying for the live sessions, so try to be as interactive as you can. Otherwise, it's just like a recorded session where you're just listening to me. All right. Okay, so let's move on. Some of the prerequisites, we don't need this today. But starting tomorrow, make sure that this is there, which is get a free AWS account. So if you already have one, well and good. But if you haven't yet, just go to the AWS website, which is aws.amazon.com, and just sign up for a free account, right? It's a free account, but they will ask you for a credit card information so that they can bill you later if you use something over your free limits. There are certain free things within AWS which you can use without paying anything. So almost everything that we are going to do in our labs, guys, is going to be absolutely free. All right. In the sense that we can do it within the free tier that AWS is offering us. So you don't need to pay anything extra. So you will be using this free account while we are doing the labs on your side to do the lab. So I will be doing the labs on my account and I'll be showing it to you on my screen. At the same time, you will also be following what I'm doing and doing it on your side in your account. All right. If when we are doing the labs, if there is anything that is chargeable, I will let you know in advance that that is chargeable so that you can decide whether you want to do it or not. For example, Route 53 is a chargeable service. So I will inform you at that time. Then you can decide whether you want to just do it on your side or just look at what I'm doing. You need a system that does not have any security limitations. So if you're working on a work computer, sometimes what happens is you're not able to run applications like PuTTY and Heidi SQL, which will need to kind of connect to databases and things like that. So if you have your own personal computer, well and good. But if you have a work computer, please make sure that there's no security limitations on it so that you can actually do the labs. Otherwise, it's going to be a problem. We will need a domain name for when we are doing the Route 53 session. This, we don't need it today, tomorrow. We will need it one day before we do the Route 53, which I believe was day 8, if I'm not mistaken. So I will be giving you a free domain name as part of this session, which is free for your own personal use for the next 1 year. So basically, I'm giving you a free domain for the next 1 year. Now, if you already have a domain, well and good, please feel free to use that. But if you don't have one, don't worry. I will provide you one as part of this session so that you can actually use the Route 53 service. At the same time, you can use that domain name for the labs that you'll be doing every time, so that rather than trying to connect to IP addresses, you can actually connect to domain name and see how it works. Any questions, guys? All right. So let's look at what we are going to do today. Today is going to be about introduction to the cloud and talking about what is AWS. So we're going to take a sneak peek into what is cloud computing. We're going to try to understand the basic core concepts of cloud computing. Then we're going to talk about different service models within the cloud and also the different deployment models or delivery models, so to speak. Then we are going to take a look at what is AWS. We're going to take a look at the global infrastructure that AWS has built up over the years. And then finally, we will wrap it up by talking about the shared security model that we have within AWS. And if you have any questions, apart from during the session, we can always take it at the end. Okay, introduction to cloud computing. So one of the basic fundamentals of cloud computing is obviously the question of what is the cloud? Now, like I mentioned, I like these sessions to be interactive. So what I want to do right now is ask each and every one of you, what do you think the cloud is? All right. You don't need to be right. Don't worry about you being wrong or anything. Just tell me what is your understanding of what the cloud is so that we are all on the same page. Anybody? What is a cloud?
So I would say anything which is not on your on-prem, like something which you can imagine, which you cannot really physically see that's what I call cloud.
Okay, so basically you're saying anything that is not on-prem, right?
Not on-prem, yes. Right.
Okay. Anybody else?
I think it's a.
Go ahead.
Yeah, I think it's a cluster of computer systems which can be used to offer IT services.
Okay, it's a cluster of computer systems which is offered for IT services. Okay, anything else?
It's Vijay here. I would say it should be on demand availability.
Okay. Anything else?
A set of resources that are available over internet.
No, you already said cluster, right?
Mhm.
Okay, just hold on. Let me see if anybody else has a different. Anybody else? Any definitions? Okay, so I think it was Abid that said not on-prem, right?
Right.
So the question of what is the cloud, and when you say not on-prem, well, anything that is not on premises becomes the cloud. Like, for example, you have a server somewhere else. Does that mean that is the cloud?
Not always, but like I have seen in my scenario, like we have started seeing the servers disappearing from our data center, and we are subscribing to cloud services, right?
Right. So
So
you're
definitely,
talking about where
right,
something is being moved from one location to the other, but that
right.
doesn't define what the cloud is, right? You're
Mm,
just saying you're just telling me where is the cloud, but my question is what
right.
is the cloud, right?
Mm.
So think on that for a second. I think Rajesh, you told cluster, right? So anything that's a cluster is a cloud. So cluster already existed from several decades ago, right? You put three computers together or two computers together, it becomes a cluster, right? So how is that the cloud? Because that used to exist before the concept of cloud came out, right? So how is
So
it different?
this, I did not mean by the infra cluster. I meant like
Hmm.
multiple computers coming together
Hmm.
to give like bigger compute services.
Okay. Did you actually watch my first video, Rajesh, by any chance? Previous one?
Not really.
Okay. All right, fair enough. Okay, so you're saying multiple systems coming together to provide a service. All right, fair enough. Okay, someone said on demand. So this is defining what the cloud is, or are you telling me a feature of the cloud? What is this? Is it a feature?
I'm telling one of the future.
All right. But I'm looking for the question of what is the cloud. So on demand is definitely a feature. I agree. So there is clustering happening within the cloud, but there is also clustering outside the cloud where, for example, I can go take a service from another data center, which is providing me database functionality. It is providing me compute functionality. It is providing me network functionality. I'm combining all of that and I'm using it, but I can't call that as a cloud yet. And obviously, just because something is not on my premises, I can't call it a cloud. So what is the cloud?
Maybe if I can add cloud means it should be run on top of internet.
So then that would mean everything else that's running on internet is the cloud, right?
Um, I would say it's a set of services
Mm-hmm.
where, or I would say like combining set of computers and infrastructure and a provider who provides a set of services which we don't have to manage it.
Mm-hmm.
You are just leveraging those services to manage your requirements, like kind of
So you're
application.
kind of going towards the feature of the cloud, because
Yeah,
when you use the cloud, that basically means that you don't have to manage it, right?
exactly. You don't have to
But
manage
that's
it because
but
it's
that's
set
a
of like
feature.
yeah, or I would say it's a set of servers and storage devices combined together that forms a cloud solution. Um,
You're telling me how the cloud is set up, but you're
yeah,
not telling me what the cloud is.
yeah,
Yeah, I'm just trying to, pick everyone's brain. Okay, I'm not saying you're wrong. I'm not, because all of you are right. Whatever you're saying is either a feature of the cloud or defining how the cloud is set up and things like that. But again, I'm looking for that golden description of what is the cloud.
I can also add to this
Hmm.
in a way that like it is more of an evolution of IT infrastructure services. In the beginning, like it started with like having own data center and
Hmm.
managing your own systems, including like hardware and services and applications and services, right? Then we moved into hosting services,
Hmm.
wherein like we took the services of vendors who are providing the space
Hmm.
for your systems and hardwares, right? Which is like more of a managed services also. And then now it is moved from there to cloud, wherein like one large player, right, who is like taking the overall responsibility of providing you all of the IT services that you can think of in various platforms, right?
All
And
right.
this actually moves your OPEX to CAPEX. So that's another
Okay.
thing that comes into play.
So would I be wrong if I told that you just explained to me the evolution of the cloud? Yes.
Yes, yes.
But what is the cloud? You told me how the cloud became the cloud, but like, where is it? Like, what is it?
Yeah, cloud again. It's a network of multiple systems which provides you. It's more of a distributed compute, right? Wherein like your system does not sit in your own place, but it's a service provided by someone else, and you are just making use of it. You have
You're
access to make
right.
use of it.
You're right. But then my counter question to that would be, we already had distributed computing before the concept of cloud came. We used to have data centers across globally where we used to distribute our applications and have it working like that. So why was that not called a cloud? Why are we calling it cloud now? Amit says storing and access of database. Storing and access of okay, that's kind of a service within the cloud, right? So it doesn't define what the cloud is. Okay, last chance. Anybody want to give it a shot?
It's a data center basically.
Then why didn't we call all the existing data centers as cloud till date? Why was it just in the last 10 years that we started calling them the cloud?
Like a shared data center instead of dedicated.
So you know the concept of like, have you
Colo.
heard about soft layer and all of that? IBM bought over a company called SoftLayer. So before when the cloud concept, before it became kind of mainstream, we used to still get shared resources from different data center providers. So there used to be this company called SoftLayer. There used to be something called Trunk Internet,
Rich.
etc. Right. So we still could purchase shared services from these data center providers, right? You either you purchase co-location space where you can go keep your own server in their data centers, right? We could do that before. You can still do that if you wish to, or we could actually rent out a server from one of these data center providers, right? But how is that different? Was my question. Anyways,
Yeah, maybe I can try one more time, Faisal. So
sure.
in my view, right, the cloud computing is kind of a best practice or practice how the technology will enable to have the infrastructure as a service, and secondly, platform as a service, and lastly, software as a service. How we can manage these three different components over the internet.
All right, fair enough. So we will be talking about those three services that you mentioned, software as a service, platform, and all of that. But again, those are components within within the cloud, and you're right. Okay, so I will relieve you all from the pressure of thinking about what this is, and let me try to explain this to you. So the reason that we are not able to kind of define what the cloud is because of the simple fact that cloud is not a new technology. All right, cloud is not something that was discovered or found out within the last 6 months, or I'm sorry, within the last 10 years or something like that. It's not a new technology. It always fundamentally was just a basic implementation of how IT services used to work. IT infrastructure. So if you set up IT infrastructure in a particular way, you can either call it a cluster or you can either call it a cloud. All right. The concept of how cloud works today used to exist before the word cloud came around. But let's anyways just try to make a little bit more sense of what it fundamentally means. All right. So if someone asks me what the cloud is, I would basically show them this picture. Now, obviously, I'm not talking about the cloud up here. I'm talking about the cloud down here. All right. So what is this? This is a picture of a Google data center. Now, why am I showing you a Google data center picture during an AWS session? That's basically because AWS does not want or does not publicly disclose where their data centers are. I mean, it has been, discovered by different people, researching and finding out where their locations are, but AWS publicly does not disclose where their locations are. So we kind of have to do with the picture that we have, right? So this is a picture of a Google data center. So what has a data center got to do with cloud, right? your cloud basically exists inside this, right? So it's definitely not up in the sky or anything like that. It's somewhere in a location that your cloud exists. Now, what is inside this location? So inside this data center, you have this. If you look at what these are basically rows and rows and rows and rows and rows of racks, right? So these are all racks, which if you take a closer look at what these racks contain, you'll basically see this. All right. So this is one of those rows of one of these systems, right? So in one of these rows, each one of this is basically a rack, right? So you have several racks in that are close together, and you have thousands of them. And in each of these racks, you have servers, right? So each one of this is basically some sort of server. They might be a general purpose server. They might be a compute server. There might be a networking server. So you'll find all different kind of servers inside this. Now, what has the cloud got to do anything with this? Now, when I say the cloud exists inside this location, think of it like this. When two or more systems come together to act like a single system, that's essentially what the cloud is. Let me repeat that. When two or more systems come together to act like a single system. So in the backend, there might be more than one system, but for you, your visibility is just a single system. So for example, I might take, this might be a storage server here. All right, this server might be, we're assuming this might be a storage server here. And let's say this is a networking server here. All right. And let's say this is a compute server. So what I'll do is I will combine the resources of all of these three services together, and I will basically run something which is basically what the cloud is. So I will combine the memory, I will combine the compute, I will combine the networking, and I will run this as a single service or as a single system. So for me as a user, when I look at this, I only see one thing, right? But behind that, there are multiple systems running, right? So that's kind of what I would define the cloud as. Now, if you ask me what are in these racks, there are different kinds of servers. Like I mentioned, there might be like, this is kind of a storage server, right? And this is kind of like a general purpose, this is a networking server. And this looks like a general purpose or a high density memory server, right? So you have different types of servers that are there. When I combine all of this and try to run them as a single unit or run them as a single system, it's basically the cloud, right? So you might ask, hold on, we used to do this long before the concept of cloud. Of course we did. That's called clustering, where you cluster services together and you try to run it as a single unit. So like I said, cloud is not a new technology. It already used to exist. But how cloud is different, we'll see in a second. So again, if someone asks me what is the cloud, I will basically say it's two or more systems coming together to act like a single system. So for example, if I take some disk, CPU, and memory, I combine or cluster all of them together in some kind of a data center or something, it's essentially what the cloud is. Now, when I combine all of this and I provide a service to someone, that's basically what a cloud application is. All right. Any questions here? So like I mentioned, most of the stuff that you guys have said so far in terms of when you define what the cloud is, you're not wrong, right? Of course, the cloud includes storage. Of course, the cloud, it's about not being on-prem. That's a feature of the cloud. So all of these were features, but when you try to define what the cloud is, I would fundamentally say that when you have one or more systems coming together to act like a single system. Now, what this also means is that you can basically you don't need a data center to run a cloud. You can run a cloud locally within your house if you wish to. Let's say you have a laptop, and maybe you have two laptops, right? What you will do is you will install some kind of software which kind of combines the resources of these laptops, and basically you can make these laptops as the servers of the cloud, right? So you can use something like OpenStack and combine the resources of these laptops, and you can basically run a cloud service. So you don't need to be in a data center. You don't need to have high-end power systems or anything like that. When you combine two or more resources together, fundamentally to act as a single system, because as a user, as a user, when you look at this, you're only seeing a single entity, but behind that or underneath that, there are multiple servers or multiple systems that are running. So that's essentially what the cloud is. Okay, so like I mentioned, when you have multiple systems working together to act like a single system, you get the cloud. All right. Now, remember this. This is my definition of the cloud. You can have your own definitions of the cloud, but I'm basically trying to say fundamentally at the core of it, this is basically what a cloud does. Okay. We've already been doing this for several decades. It's just a word that came out, and we will, in a second, we will discover what is the significance of that word. But underneath all of it, it's like any other clustering. Okay. So multiple systems working together act like a single system is the cloud. So now if I ask you, let's say I have two cloud systems. Okay. So multiple systems working together act like a single system. But here in this diagram here, I have two cloud systems, or I have multiple groups of cloud systems that are supporting the same function and working together. What do you think this would be called? Again, you don't need to be right here. Just tell me what you think this would be called.
This will still be a cloud.
It is still a cloud, definitely. But what kind of cloud is it? Anybody?
Private cloud?
No. So a cloud can be private or public. Now, whatever I'm showing you here, any of these clouds can be private or public. So this does not define what a private cloud is, right? This can be a public, this can be a private. Doesn't matter.
It would be more of an application as a service. Means you're providing someone a set of, like you have what you're showing as per the diagram, right? It has a database, it has storage, and all other components. So configured, and now you're providing that service to someone.
Yes, but my question here is that, let's say this one thing is, let's say my one cloud system. So let's say this includes my database, my EC2, my server, or whatever. Now I have two copies of it here, right? And I'm running those copies simultaneously, supporting the same function. Both of them are doing the same thing. So what do you think?
Okay, so it can be high availability cloud.
Well, not yet. It's getting very close to high availability, but it is not yet, right? So I wouldn't technically call this a high availability cloud.
Distributed environment.
Come again?
Distributed environment.
Distributed and high availability are kind of interchangeable words, right? So when you say high availability, you assume it's distributed. So it's not yet. It's getting very close to distribution, but it's not yet.
More of a clustered, I would say, but running in the same location, using the same resources.
Is there a better word for that other than cluster?
Okay. I mean, I was looking for the same thing. I was not able to recall.
Okay.
Something like that.
In any of those terms, regions?
No, we're not yet going into regions, but not yet. So just assume that this is one data center. So this is in a single location. So this is not like spread across regions. All right. So this is at the least what you would call this is, you would call it a load balance cloud. Why do you think it's a load balance cloud?
It distributes the load.
Right. Across. So I have two environments. Okay. I have one cloud environment and I have another cloud environment. My load is distributed between these two environments. So this might be my environment 1. This might be my environment 2. Now remember, I have two set of cloud environments. Although I'm running everything in the cloud, within the cloud, I'm creating environments. So I have two separate cloud environments. Both of them are doing the same thing. So as a customer, I might hit this one or I might hit this one as well. Now, of course, there is some kind of load balance or something that's going to come in between, but this is a load balance cloud, right? My load is getting distributed across this. Or even you could call this a failover cloud or something like that, where one is active and one is standby, right? So that if the active fails, then the standby can take over, right? So you can call this a failover cloud as well, if you wish to. But if they are working simultaneously at the same time, they are basically a load balance cloud. Agree? Make sense?
Faisal, one question.
I mean, right? Sorry.
So, sorry, 1 second, Abid. Yeah.
Yeah. So Faisal, one question here, like as you mentioned, like load balance cloud, right? So let's say on left hand side, are we going to use network switch from left hand side and storage from right hand side, and compute from like from side A and compute from side B, or like I was just trying to understand, like, are we going to mix and match of these infrastructure component from each side, or these components are going to work within their own, one set of frame?
So how this works is when I mentioned what the cloud is, I told you that there are multiple systems coming together to act like a single thing. So if this is what
Right.
you call the cloud, this might be your database, this might be your server, this might be your application or whatever, right? So inside this, you contain all of the resources required for completely running your application alone, right?
Right,
And then you
right.
have a copy of that somewhere else that
Mhm.
is also the same thing, right?
Okay.
So that is how it would be. But it's not that you can't mix and match. You can definitely mix and match if you wish to. But the problem is if you mix and match and one goes down, then you're kind of handicapped because some of your stuff is there where you need to work, but that's down, right? So you wouldn't do mix and match in this scenario. You would
Okay.
basically have copies of your entire environment. So if you have a database, you have a server and everything, you would create a copy of that in the other environment.
Perfect. Great. Thank you. Got it.
I'm sorry, someone else had a question?
Yeah, Bill. So this, can we call it like an increased capacity of the cloud, like in a multiple groups, and those are load balanced?
Yeah, this is definitely going to increase your capacity, but again, this is also going to increase your cost. But at the same time, I wouldn't technically call this high availability, right? Because high availability means even when you have a failure, even when you have multiple failures, your application is still running. Now here, when you're talking about failures, you only have the chance of a single failure. Let's say this one environment fails. Now you're only left with one environment, right? So if this environment goes down, then you're done. So basically when this fails, you become something called a single point of failure. Once you're in single point of failure, you're no longer high availability, right? So this is not exactly high capacity per se, but yeah, you have a better capacity than just having one environment, right?
Same with the load balance also, right? If one of this fails, then all of your load is going to fall on the other one only, right? So
Correct.
it's kind of
So
same.
if your load is distributed 50-50 and then one of the environment fails, then suddenly one of the environment has to take 100% load, right?
Right. So in that case, like load balanced and high availability both can be interchangeable, right?
I will show you in a second how the difference is. All right. Any other questions? Okay. Now this one. Now I have a single environment over here that was a cloud, but here I had two copies of that environment, but basically in a single location, right? But here you can see that I have multiple locations, which basically is that I have multiple data centers that have multiple groups of cloud systems within them that are all performing the same function. What do you think this would be called?
Highly available, maybe.
Right. So it was obvious from the previous one that would be the only thing left. So this is known as a multi-region or a high availability cloud, right? First of all, you call it multi-region because of the fact that you're having it across multiple data centers across multiple locations, right? So you call that multi-region. Now, the word region in AWS has some specificity to it. We'll talk about that a little bit later on what a region actually means. But just understand that it basically means different locations, all right? And how is this high availability? Now, in this case, we have 4 copies of the environment across 2 different locations. Now, for example, within, let's assume that this is data center 1 and this is data center 2. And in each data centers, I have 2 copies of my environment. Now, let's say within data center 1, something happened to a certain section of the data center. And let's say my certain set of applications working in one side of it failed. Is my application still running or not? My application is still running, yeah, and it's running across 3 other copies. Now there's nothing that is impacting per se because my load is getting distributed across all of them. But what happens if an entire data center fails? Because that does happen, That does happen, where an entire data center or an entire region goes down. Let's say some flooding happened in one of the locations, and all of the data centers there, the power went down, the internet went down. So that does happen. Now, when that happens, is my application still running? It is still running. Yes, it is running at another location. So this is how you achieve true high availability within the cloud, where you're not just setting up a single environment in a single location, and you're not just setting up a copy of that environment in the same location, but you're also making a copy of that in another location, so that any chance of simultaneous failures is completely ruled out, and you have at least some of your application running somewhere. Any questions?
Yeah. So in that case, the provider of cloud providing you more capacity from storage side, compute side, and network side, right? So definitely there'll be some extra charges for that, right?
The way I would put this is, think of it as simply as this: if this environment costs $10, okay, this environment is going to cost you $20, and this environment is obviously going to cost you $40. All right.
All right, that's
Because
right.
you're trying to duplicate it. Now, obviously, when you do multiple environments, some of the stuff will get balanced out, and it's not necessarily a multiplication like this. It might be like 10, 15, 30 kind of, all right? Because the more you use, sometimes you get bigger discounts and things like that.
Sure, sure. That's fine. Thank you.
All right. Okay, so I hope a little bit concept of what the cloud is clear. Now, remember that you can apply this concept across any cloud provider, all right? Whether it is Azure, whether it is AWS or Google, the concept kind of applies the same. They have different names for calling what a load balance is and what a multi-region is, but kind of it's all the same at the end of the day. Now, remember, this is a very simplified explanation about what the cloud is, but I want you to think of it in this way, because once you start thinking of it in this way, everything else will just simply start making sense. All right. So hopefully this makes sense. Let's move forward. Okay, so we know what the cloud is right now. We know how it works, but we are still left with a question: what is the cloud? We know how it works. We know what is behind it. We know that when you have multiple systems together, it is called the cloud. But then if that is the case, then everybody will start calling it the cloud with whatever they are building, right? So you might have two systems with you, you combine it together and you say, I'm a cloud provider. You could do that technically, right? But then somebody has to make a rule to define what the cloud is. Thankfully, somebody did. So NIST, or I believe that is the National Institute of Standards in Technology, that's in the US, they defined what the cloud is. Now, when I say they defined, they said that there are 5 characteristics to something to be called a cloud, right? So if you want to call something cloud, it should meet these 5 characteristics. Because what used to happen is, when the word cloud started coming in about the last 10 years, everybody started calling whatever they were selling as cloud, right? So before, you had your data center providers that were renting you space in their data centers, right? Renting you servers in their data centers. What do you think they called it now? They called it cloud servers. Now, some provider was giving you storage before somewhere, and suddenly when the term cloud became famous, they started calling it cloud storage, right? So rather than just everybody just slapping the name cloud onto everything that they're selling, somebody had to define what that is. And these are those definitions. There's 5 definitions, which is on-demand self-service, broad network access, resource pooling, rapid elasticity or expansion, and measured service. Let's look into detail what each of these mean. The first one is on-demand self-service. So if you need to call something the cloud, it has to be on demand and it has to be self-serviceable. Now, what does it mean? If I were to compare this, let's talk about a few years ago. I mean, it still happens, but some of you might have experienced it a few years ago, which is, if you needed a server within your organization, what are the steps that you had to go through? Anybody who had done any kind of server provisioning?
Yeah, like it start from getting approval from finance, and then put together requirement, goes to the procurement, get the server on-prem, do the cabling, connecting to storage, and connecting to your backup infrastructure, like tons of, all these steps which normally take like a lot of time, like maybe sometime over a month, depending on how your organization works.
Well, if you're doing it within a month, you must be doing something very good, because normally that process takes at least about 6 months from the time you decide you need a system, right? So from the time you decide that you need a additional server, you have to put in the approvals come through provisioning, it goes to the vendor to provision it, the vendor provisions it, and all of the stuff. And finally, when you get access to it, it's several months down the line. Now that is definitely not on demand, right? So if you are still, if your cloud provider is still doing that, then that is not a cloud provider, because there are several providers as of today. Abid, your mic. There are several providers still today that claim to be cloud providers, but when you ask them for a server, they have to do all of this in the backend. Basically, they have to provision it. So it might be shorter time period, 1 or 2 days, but it will still take time. So that is not a cloud provider. And that's what on demand means, which means you request for a server right now, you should get it within an expected short period. Now, I'm not saying like this second. So if I request a server right now, I'll get it within the next minute or two, right? So if I want something on AWS, I just go and click a button which says start a server. And as soon as the server starts, I have that machine with me, right? But what is this concept of self-service? Now, if you were to, let's say you wanted the server, right? You are not the person who's provisioning it, right? You have to put a request. Somebody else has to go provision it. Somebody else has to go set it up. None of that is a self-service process, right? There are so many people that are dealing with it. But here in the cloud, if you click on something, you get it. You don't need anyone else to set it up for you. Because what used to happen is all these providers who started just calling themselves cloud providers, when you requested a server, there was someone sitting in the backend processing your request and provisioning a server for you, and then that showed up on your dashboard. That is not the cloud, right? Because there is someone else involved in that process, someone else doing it for you. So it's not a self-service. So if that is the case, then that is not the cloud. So if you want to call a service the cloud, it should be where if somebody is requesting something, they get it immediately within a very short expected time window. And also there is not someone else who's provisioning it for you. So if we go back to the concept where you built your cloud, you took a couple of PCs that you had lying around and you combined them with some OpenStack and you built a cloud. And if someone requests a server in that, what happens? You have to go to your console, you have to provision it and then give them that server, right? So that's not the cloud. Although technically you built a cloud, that's still not a cloud. All right. Let's move to the next point, which is broad network access. This basically defines two things. Okay, so the first thing is that this should be accessible from anywhere. This is access from anywhere. Also, this is access from any device. So when you set up the cloud, there are some defaults. Of course, you can go ahead and secure them a little bit later on, but by default, if you create a cloud, if that cloud is only accessible from your office, or if it's only accessible from a certain region, then that is not the cloud. So if you build a cloud, that should be accessible from anywhere in the world. All right. Otherwise, that's not the cloud. Now, of course, once you build it, you can go ahead and put in security constraints saying that only people from a certain region or only people within the office are supposed to access it. But that is secondary. You're actually putting in a control after you create it, right? But technically, it should be accessible from anywhere. Also, it shouldn't be like you created a cloud and people have to access it with only a laptop or only a desktop, right? Like they can't access it on their mobile phone, then that's not the cloud, right? But again, you can of course put in additional security measures which says that it is only going to work from your office laptop. Fair enough. But by default, it should be accessible from any device. Any questions here? All right. The third thing is resource pooling. Again, this is also split up into two. The first kind of resource pooling, think of it like this. I'm not sure how many of you have used that kind of service in your respective countries, but have you used Uber pooling? Uber pooling, anyone? So it's basically where you are sharing a single resource, or you're pooling a single resource. So in this case, think of the Uber cab being as a server. Okay, the cab here is a server, and the people that are in the cab is essentially your applications. So you're using a single server to run multiple applications. You're basically pooling the resource in one sense. Okay, this is one type of resource pooling. So if somebody gives you a server and they tell you, okay, this server you can only run one application, or you can only run this application. Well, they're not providing you a cloud service. They're providing you a server that is on the cloud, but that's not a cloud server per se, right? Because it's not allowing you to run multiple applications on it or pool the resources of that to run multiple applications, right? So that's not resource pooling. The other type of resource pooling is where you have multiple servers, right? So all of these are servers, and I'm pooling their resource to run a single application, right? So I have multiple servers, I'm pooling all of their resources to run a single application. This is also another type of pooling. This is what you would see more commonly in the cloud, where you have multiple servers that are behind a single application. Now, there might be providers who are giving you servers, but then there is no way you can combine or pool those resources. So for example, in this sense, if each one of these had 2 GB or let's say 4 GB RAM, each one of these had 4 GB RAM, essentially, what is my total capacity for my application? It's going to be 12 GB RAM, right? Total capacity is going to be 12 GB because I'm pooling all of the resources together. Make sense? Any questions? I need a few questions, or it's the case here is either I am either you all understood everything or you understood nothing. So it's either one, or maybe I'm really good at explaining all of this. So which one is it? Any questions?
No questions.
All right. Okay, so that was the third option, resource pooling. The fourth option is rapid elasticity or expansion. The simplest way to think about this is think of a rubber band, right? A rubber band obviously has a normal state. Now, what you could do is you could stretch that rubber band. You could stretch that rubber band, and obviously, when you stretch it, it becomes all stretched out. What happens if you let go? What happens if you let go of that? It'll obviously come back to the original shape. Yes. So think of your services on the cloud in the similar way. Let's say you had 2 servers. Okay, you had 2 servers. Now you want to expand your capacity, just like how you pull this rubber band apart, right? So now you added more servers. You expanded your capacity and you added more servers. But now let's say your requirement is done. You no longer need those servers. You go ahead and delete those servers, which basically means now you're contracting back to your original requirement. This is what elasticity is within the cloud. Now, a lot of providers, when the concept of cloud came around, a lot of providers who started just calling themselves cloud providers or cloud servers or things like that, they used to give you servers, but they used to give you those servers for like a month or a year subscription, things like that. So if you bought an additional server, you are basically stuck with that capacity either till the end of the month or for the entire year that you had asked for it. It was not elastic. If you had 2 servers and you needed additional capacity, you either had to pay upfront for it for the whole month or for the whole year or something like that, based on what your contract terms were with them. That is not the cloud. The cloud is where you can add servers, remove servers, do whatever you want in terms of your capacity, because it should provide you full elasticity. If there's a provider that's doing something else, then that's not a cloud provider. Any questions?
But Faisal, based on the cloud solution, this is more in a general terms that you're talking about, right? Rapid elasticity.
Right.
Because in order to achieve this in a cloud environment, means you have to do a couple of automation, or like you have to have that tools to do this kind of functionality, right? It doesn't come by default.
So we are talking about what would you call the cloud, right? So we talked before where I told you that, you could build your own cloud, or there used to be people who used to sell something and they used to just call it the cloud, right? We are trying to understand the definition of what is a cloud. So if you are providing a service that in the backend does not have all of this automation already ready, and you are trying to use that service and it is not elastic and it is not on demand, then obviously you can't call that service a cloud service. They are a data center provider, they provide you service, but you can't call that a cloud service. It's not about you having to implement this. This is not a case where you go take a service from a cloud provider and then you are implementing that automation. No. Yes, there is some level of automation you do, but you are not automating the provisioning of those resources. I mean, you are not the one who's actually in the backend setting that up, right? You are going to just tell them, when I need additional capacity, I need these many servers. That will be automatically provisioned by the cloud provider. If the cloud provider is not able to provision that to you according to your requirement, if they don't have that automation, then that's not a cloud. That's what we are trying to differentiate here.
Okay, got it.
All right. And the last one is measured service. Now, as simple as this sounds, this is probably one of the most important ones, because when you talk about a measured service, you need to know what is happening in your environment at any point in time. Whether that be your CPU utilization, whether that be your total memory utilization, or how many customers are coming, or what is the load into your environment. If you're not able to measure all of this service, then there's no real point in you running in something called a cloud. Also, in the same point comes billing. So if you remember, if you have worked at least in the last 10 odd years, when you used to take these services from other providers, like you went to a data center provider and you bought a service, what normally happens is you get a bill at the end of the month, right? And when you get that bill, you realize that, okay, there were these servers running which I did not need, or you get a shock or a surprise and not knowing why the bill came this much. This is because you are not able to measure your total cost every single day of your usage. Cloud providers are supposed to provide you that. If they don't provide you that, it's not a cloud service. So as an example, on AWS, you can literally see what is your total cost every day, right? So if I go look into my billing control panel today, I should be able to see the cost of my resources till yesterday. Now, of course, we are not talking about cost estimation tools. That's a different story. I'm talking about the actual cost of your resources that is currently running, right? So this way I'm able to make better decisions. I can save money where I need. Otherwise, what happens is, you had a contract somewhere, and then at the end of the month, you get a bill, and then you realize you didn't need these resources, right? So measuring a service is also as important as all of these other features like elasticity, on demand, network access, self-service, all of that. Any questions?
Faisal, I have a question here. Like these major service, these are based on the actual like infrastructure provision, or like these services are built up to the storage and network devices and your backups and everything.
So think of it like this. Let's say you took something on AWS. Let's say you took storage on AWS and you have networking on AWS and everything like that. You should be able to know how much storage you're using at this point in time and how much you used till now, right? So you should be able to measure each and every day's performance, not just how much you're storing, but what is the performance of that? Like what is the read and write speeds onto your storage? Also, when it comes to networking, you should be able to know what is the total throughput of your network, right? What is the different kind of network blocks or access logs that you have set. So everything should be measurable. So we are not just talking about a single service. Any service that you get from a cloud provider, if that is not measurable, then that is not a cloud service. Because what happens is, anything that is not measurable is normally somebody sitting in the backend and doing that calculation for you. Like when you go to a third-party provider and you ask them a server, they will give you the total cost of the server for the whole month or something like that. They were not going to give you the details of how that cost is achieved, right? But with AWS, you are able to look at the individual breakup of what each of the cost is, and you're able to control that, right?
Okay. So basically, you are just joining the dots and making your own solution.
Yes, sort of that.
Great.
You
Perfect.
get better control over defining your architecture.
Perfect. Great. Thank you.
So further question on the same lines, right? So say for example, at the time of server provisioning, I added 50 gigs of storage, but I'm using only 5 gigs of storage. So will I be charged for 5 gigs or 50 gigs?
So this is a question about different types of services. Some services will charge you only the pro rata. Some services might charge you the whole thing. For example, when you talk about EBS volumes, which is the hard disk of your servers, that is charged for the whole thing, whether you're only using 5 GB or not, right? But when you talk about something like S3 storage and things like that, you're only charged for what you're actually using. However, within that first thing that I mentioned right now, where EBS, you are charged for the whole thing, you are still charged pro rata. For example, let's say you took a 50 GB hard drive for your server. You will be charged for the 50 GB over the whole month, right? So let's say you took a 50 GB disk and after 10 days, let's say you deleted it. You are going to be charged only for the 50 GB for those 10 days. Does it make sense?
Yes.
I mean, even if you only used 5 GB, you will still be charged for the 50 GB, but that'll only be charged on the pro rata basis of how many days you actually had that disk with you, right?
So it's a time measure, not the capacity measure.
Depends on the service. Depends on the service, right? The service sometimes, if it is like an EBS service, you are done on the total time. But if you're talking about something like S3, you are charged both on the time and the capacity.
Okay.
So we'll see those specifics of billing and all of that once we start looking at each service. So when we look at something like S3, we will discuss how the billing for S3 happens. When we look at EBS, we'll discuss that part, right? But overall, just understand measured service basically means two things. One is you're able to measure the performance of your environment. You're able to look at how your environment is handling everything. And of course, know your total cost till that point in time. Okay, let's talk about the different computing models that are there. So when you talk about service models, there are three types of service models on the cloud. And we're talking about deployment models. There are three types of deployment models. Now, remember, we are still not yet talking about AWS. We are talking about cloud in general. All of this is applicable across all of the clouds. Now, think of service models as to what the cloud is built for or how the cloud is configured, and deployment models as to how the cloud is set up or how the cloud is built. Okay, so think of service models as a configuration of the cloud and deployment models as the setup or the or the final state of a cloud. Okay, we will discuss what this is. Now, as far as the service models is concerned, I'm pretty sure you've all heard about this concept of SaaS, PaaS, and IaaS, which is software as a service, platform as a service, and infrastructure as a service. Now, over the last few years, you have got different variants of this. For example, you have got database as a service, you have got backend as a service. So there's a lot of variations. However, all of these variations will in one way or the other kind of be more towards one of these categories, right? So for example, backend or a database as a service, that is going to fall somewhere in between PaaS and SaaS, but that is more towards PaaS. All right, we will discuss what each of these are, but I'm just trying to tell you that all of those different ones that you hear about, like database as a service, backend as a service, or identity as a service, etc., etc. Either they fall completely into one of these categories, or they are somewhere in between this and more leaning towards one of these categories. All right, but let's try to understand what each of these are. So to define what this is, we have to understand how the cloud is set up. Now, if you were to set up your own infrastructure, right? You have a private data center or you have your own systems and you're setting up everything yourself. So when you do that, what all do you have? You have to set up the networking, the storage, the servers on top of that. You have to create the virtualization for the VMs to run on top of that. You have the operating system that you are controlling. all the middleware, the runtimes, the data that you're putting on top of that, and finally the application that you're running on it. So this entire stack, when you build something on your own, whether that be in your own data center or just in your own home, you're doing two systems together. The idea with this is that in a private model, you are going to manage everything yourself. You have to take care of this entire stack. No one else is going to help you. Now, when you talk about service models, when someone else is providing you this service, they are going to take care of some part of this, right? So for example, when you're talking about IaaS or infrastructure as a service, in this, the service provider who's giving you this IaaS service, right? The company that is providing you this IaaS service, they are the ones who are going to take care of the core infrastructure part, which includes the networking, storage, the servers, and the virtualization. Everything on top of that is still your responsibility, right? So let's say you went to AWS and you took some IaaS services from them, which basically means you are taking services where the core is managed by AWS, and then you, on top of that, you are running your own stuff on top of that. This is what infrastructure as services. Now we will come back to this in a second. When we look at platform as a service, similarly, a provider who's giving you a platform as a service is going to take care of certain aspects of this stack. Which are the aspects? They will not only take care of your infrastructure, they will also take care of some more part, which includes the platform that is running on top of the infrastructure, which includes the operating system, the middleware, and the runtime, right? Now, you still have to control what data that you're putting on it and what are the applications that you're running on it. And finally, we have SaaS. What do you think this is?
So it's ready to
Everything.
go. Yeah.
Yeah, I mean, in terms of the stack, what do you think it is?
It's more of an application, I would say.
Yeah. You just
No.
need to have your username
No,
and
you-
password just to log
You
in.
just use it. Yep.
Yes, but in this, what all do you think they're taking care of?
Everything
Everything.
up to application stack.
Correct. So it's the exact opposite of a private model where they have everything. They built everything. Everything is configured already. You are just using that service. Can anyone give me an example of a SaaS? The simplest example of SaaS?
Zoom that we are using right now.
Gmail.
Well, yeah, I mean, I
Salesforce.
was looking for Gmail. All right. So Gmail is the simplest example of a SaaS because of the fact that they built a service meant for something and you're using that service. You cannot modify anything underlying in Gmail. Like, can you go ahead and modify the servers that are used for sending emails via Gmail? You can't. You can't go ahead and change their stack. Can you change what are the protocols that are used for sending the emails, like the port numbers and all of that? You can't, because they built a SaaS, they built everything. Everything is taken care by them. You are just using the service on top of that. Okay, can you give me an example of a PaaS? Think about this for a second.
Like a SQL Server on Azure, I'm aware of on the PaaS SQL on Azure.
Okay, close enough, but okay, I will take that because there is a similar service on AWS as well.
What about AWS?
See, AWS provides you all of this. AWS provides you IaaS, PaaS, and SaaS because there are some services on AWS that have an IaaS model. There are some services on AWS that run on the PaaS model, and then there are some services that run on the SaaS model. So different services are there within AWS, and you will see all of this across AWS.
Okay.
Any other examples? A more
I
simple.
think all the servers provisioned on cloud are PaaS, right?
Not
Like
necessarily.
when you spin a server, say for example, you spin a Windows server or Linux server, you are getting the server along with OS and everything. Is that right?
That falls under the IaaS. I'll tell you why. For example, on AWS, if you spin up an EC2 instance, which is basically a server, when you spin that up, they are only taking care of the underlying infrastructure, which means the physical servers which that virtual machine you just spun up on is running, and the underlying hardware. However, they are not going to update your operating system. From that operating system on top, upwards, you have to take care. So once you start up a VM, is AWS going to log into your VM and update your VM? No, they're not going to do that. That's your responsibility, right? So that's an IaaS. Any simpler example of PaaS?
That MongoDB that you were showing up earlier, right? Database and then application services. And so you just
Yes, there is a MongoDB PaaS service available, but I'm looking for a more generic, which is not cloudish kind of a PaaS. Like for example, Gmail is more a generic thing, right? So any PaaS generic things like that?
it's more like I would say web servers. What do you call it? AD servers, Active Directory Services, ADFS. You can take.
Close. I mean, ADFS you can actually have in both. You can have in IaaS and PaaS.
Right.
Basically, if you're configuring the AD yourself, it's an IaaS, but if you're taking a managed AD, it is a PaaS.
Thank you.
Okay. You all know GoDaddy web hosting?
Yeah.
Okay, so GoDaddy or even us actually. So we have a web hosting service as well. It's called outpowerhosting.com. You will be getting the domain from us through that. So if you talk about web hosting, what do you get? Whether it is Wix or whether it is GoDaddy or whoever it is, in that they are giving you the platform and you are building your application on top of that. Your application being your website, right? So for example, if you go to GoDaddy or anybody who's giving you web hosting, are you managing the server that they're giving you the hosting on? No, that is being managed by the provider who's giving you that service. Also, everything that is required to build the site, which includes the platform, the application that controls the platform, is also given to you. You are only building your website on top of that and then putting your data on top of that. So the simplest example is something like a web hosting service, right? But there are many other examples. For example, like on AWS, you have database as a service where AWS is managing the database for you. You are just using the database, right? So that can be. Similarly, on Azure, you have SQL as a service, right? So those are PaaS. Is Salesforce a PaaS or a SaaS?
SaaS, everything
It's
is
a
already
SaaS.
there. Yeah.
Must be
It's a
SaaS,
PaaS.
yeah. But they provide both, right? So SaaS and PaaS also. Heroku.
Salesforce as a core service is a PaaS. There are some components of it which is a SaaS, uh, because on Salesforce you are building your tools on top of Salesforce, right? You are building several algorithms and you're building several tools on top of Salesforce as well. So in that sense, I will call it a PaaS. Of course, if you're using a Salesforce model where you're just using plugins and just running the service as it is, then it's a SaaS. Any other examples of PaaS?
Then how about Lambda services on AWS? You can push
Lambda
in your
is
codes.
a PaaS service because you are just
Personally.
giving it only the code
Right.
and it is doing everything else. You're not bothered about what is a runtime. I mean, you need
Right.
to know what is a runtime, but you're not managing that runtime.
Right. So it's a PaaS, right?
Correct.
So one question here again on SaaS, right? So you give an example of Gmail as the best example of SaaS. So Gmail, Hotmail has been there for years or decades, right? Even before the concept of cloud was coined in, right? So what did you say? Like it has been like a cloud service. Yeah, it was a cloud service from day one since it was launched.
So these models existed long before the concept of cloud came, right? So when you talk about the cloud is basically telling you that you can implement any of these models in the cloud. So this is not a cloud specific model. These are IT models that existed since the beginning of IT. The cloud providers are telling you that you can implement any of these models depending on your choice. So if you are someone who's saying that, okay, I will use AWS cloud, but I don't want AWS to control everything I am doing. I don't want AWS to manage everything for me. I will build my own service on top of AWS. Then you can go the IaaS route. Let's say you are someone who's saying that I just want something that works. So I don't mind who's managing it. If AWS is doing everything for me, then I will go with that service. So then you go with the SaaS platform on AWS. So it's your choice. But these are not cloud specific descriptions or technical. These already existed. The cloud providers are just trying to convince you that any of these models will work in the cloud.
Right. Okay.
All right. I hope this part is clear. Let's move on. Now let's talk about deployment models. And within the deployment models, you have three models, which is a private, public, and hybrid. Now there is one more model that is there, but you're not going to see that very often. It's called a community model. It's mostly used by universities which are sharing resources and things like that. But in the real world, you're mostly going to see these three models. Okay. So you have the private model, the public model, and the hybrid model. Now, very important distinction that you need to make here between private and public is the fact that we are not talking about your data security. Okay. This does not mean that your data is private or your data is public. We are not talking about your data here. Okay. We are talking about who is managing your cloud, right? So if we say private cloud, it basically means that there is a private entity that is running the cloud, which is for a private use. Okay. When we say public cloud, it basically means that there is a provider who's giving the public access to their cloud. Okay. This in no way means that your data is private or public. You can have a public data here, you can have private data here. Okay. It doesn't matter. So we are talking specifically about what are the deployment models or who is managing or building this cloud. Now let's see what in detail these are. So a private cloud is privately built and privately run. Okay. Now, this basically means there is someone who's spending their own money and building their own cloud resources using a service like OpenStack or something like that. So let's say you have a couple of data centers, and over the years you have been just using them as a data center, so to speak, and you have servers there. But now you want to move to the cloud, but then you want to move to your own private cloud. So what do? You use services like OpenStack to build, to use your existing servers, or you might choose to have new servers, but then you will use your own data centers, you will build your own setup, and you will run your own cloud. Now that will most likely be only for your own private use. Now, if you allow the public to use what you just built for yourself, then that becomes a public cloud. Okay, so that is the basic difference here. It's not about who built it, whether you are as a private organization built it or whether it is AWS that is building it, it doesn't matter. If someone built a cloud and they are allowing the public to use that cloud, it essentially becomes a public cloud. All right. If it's just a single organization that's using it, it's most likely a private cloud. Any clarifications here or any questions? I will show you a diagram, but any questions?
I have one question.
Yeah.
So can I have my private cloud hosted on AWS?
In a way, yes. So when you're talking about private cloud inside a public cloud, you're basically saying that you're using a public cloud provider's resource, right, inside which you're building a cloud that is only going to be used internally for your own use. All right.
Sort of dedicated.
Dedicated. But then that also means that you're not going to let other people access the services within that. So for example, you use the public cloud, and let's say you put a web server in that public cloud. Now web server means you are going to let public people access that web server, right? Then that's not private. Then that's not private. Let's say within the public cloud, you put your, let's say your document server, right? And then you're only using it for your internal use. Then you can still call that a private.
No, so even if my own personal data center, right? Mm-hmm. If it is a private cloud, but I can host a public or internet facing applications, right, where people can come and access, because
sure,
that's my
sure. But remember, you are not letting the public come and start their own services inside your private.
Okay. Yeah.
Right?
Okay.
So that's the differentiation. Okay, so I'll come back to hybrid cloud in a second. So let me just explore this private and public model a little bit more. So if I were to ask you, what is the advantage, or let's say, what are the disadvantages of having a private cloud? Now remember, a private cloud basically means you have your own data centers. Whether that be a single data center or a multiple data center, you will have your own servers that are there within the data center. And then you will run some application like OpenStack, which will combine all of these resources into a cloud. Then as a user, you're accessing that cloud internally. Now, no third-party user from outside your network can come and start servers inside this network. All right. They might be able to access these resources. Remember, I told you you can make your data public even inside a private cloud, but you are not letting other people come and start resources inside your cloud. You're just letting them access it. Okay. So can you tell me what are the disadvantages of having a private cloud?
We need
High
to
cost.
keep resources. Yeah, high cost in terms of
In terms of
hiring
what? Like what is
like
that?
managing the cloud infrastructure. Company need to hire the resources dedicatedly, like stop or.
I wouldn't say that is the main cost factor here, because of the fact that even if you go have a public cloud, you still need someone to start and stop your resources over there, right? Maybe you have a smaller team, but still you need those people. That doesn't eliminate people there, okay? But there is other factors. What are the other factors that contribute to the cost?
So resources are dedicated, right? For me, if I am owning that, so I have to pay for those. It's not shared.
When you say resources, you're talking about the servers?
Yeah.
Yes, but what is the disadvantage? My question is not advantage, disadvantage.
I think the whole scalability.
Okay, scalability is a challenge. I will talk about that in a second. What else? So I still didn't get the answer about the cost factor. So cost is definitely a disadvantage, but what way is my question?
So basically maintaining that whole private cloud, right? So basically your how much resources are being used or how much is not being used. If you have estimated the private cloud to like in a month that it should be using at least 80% of the resources, but if you're using only 30%, means your cost value goes higher.
Sure, but in that way, let's just say that I pre-planned it very well and I only have little bit resources, and I'm still managing only with a few people, but still my cost is going to be extremely high. But due to some other reason, I'm trying to figure out what that reason is. Of course, having people to manage those resources is a part of your cost, but what I'm trying to say is that is not your main cost factor here. There is something else, and I need to know what that is.
That's hardware is there, power, maintenance, subscriptions.
Okay.
Yeah, and that is dedicated to that customer only. That's what I was saying. So, like if you have spare resources, no one else can use that. No one can share the cost with you.
Okay.
Yeah, maybe I would say it's a human resource, right? You can't have the right skill set for you to manage your private cloud, whereas the public cloud, someone else is working on behalf of you, do all the innovation. It's basically, we don't want to reinvent the wheel. To attract the skill set to manage the private cloud, it's very difficult. As I speak from Singapore, it's very difficult to. Yeah.
Right. So that all of these are definitely a factor of the cost, but the majority of the costs that is going to come in when you have your own private cloud is the fact that you have to go buy these servers first. Even before you run a single service inside your cloud, you have to go buy servers. If you talk about the public cloud on AWS, do you have to go buy anything upfront before you actually start something? You don't. You want one server, you go start one server in AWS. But if you want to start one server in your private cloud, are you going to go buy only one server?
No.
You are obviously going to have to pre-plan and provision a lot more before you actually even start using your very first server, right? So let's say you have a requirement of, let's say, to run 100 servers. That is your actual requirement. And you are never going to just go by actually exactly 100 servers. You are obviously going to over provision a little bit. You might go by either 150 servers or 200 servers, right? Now you have to pay for those 200 servers upfront even before the first application that you run, right? So the main difference here is that there is capital expenditure or CapEx. The model on the private cloud is CapEx, which means you have to pay upfront. You have to do capital investment even before you run your first server. Now, we are not just talking about server. We are talking about actually, if you don't have a data center, you need to go buy a data center first, right? Then you need those servers inside the data center. Then you need to pay for electricity to run those servers. You need to pay for cooling to keep all those servers cool. You need to buy generators for backups. You need to literally do everything. And even before you run your first server, you have already spent at least $2 to $3 million. You understand? So that is capex, and this is one of the biggest disadvantages of owning a private cloud, is that there is so much money that you have to spend upfront that unless you are a really large company, you're never going to do this. No startup is going to do this. No mid-sized company is going to do this. They're definitely going to look for something else. Now, what is the opposite of this on the public cloud? If it's not capex, what is it?
OpEx.
Right. On the public cloud, you have OpEx, which is basically operational expenditure, which means you do not have to pay for anything upfront on the public cloud. You are only paying for what you're operating. So I went to AWS and I started, let's say 100 servers. I am only paying for 100 servers actually after I use them, right? After the end of the month, when my bill comes, I'm going to pay for them. So it is only operational expenditure. So this is one of the biggest differentiations. Now let's come to the other ones that we talked about. Scalability. How is this a challenge, or how is this a disadvantage?
I think with intelligent, planning, scalability cannot be a real challenge in private, as long as you are planning to grow based on the capacity you have planned intelligently before. But if some unusual projects comes in and you have to spin up a lot more servers than the plan, then definitely scalability becomes a bigger challenge in private cloud, because you don't have enough resources pre-allocated there.
Okay, let me combine the scalability with availability. Now, when we talked about high availability, what was one of the core principles of that in high availability?
Multi-tenant.
Multi-tenant or multi?
Multi-data center.
Multi locations.
Multi-locations or multi-data centers or multi-regions, right? So one of the biggest challenges with private data centers is when you try to achieve high availability or scalability, you always run into the problem of having to go start another data center in another location, right? So for example, let's say you are in just one location and you have one data center. The probability of a serious issue affecting that one data center is still extremely high, right? But if you want higher availability, you need to go start a data center somewhere else in a different location or a region, so that if something happens here, at least your applications are running there, right? So this is also a challenge. So this will again incur additional capex for you to even kind of move from the starting where you are going to have issues. Now, scalability it's a double-edged sword here, scalability. Because when we talk about scalability, we are talking about, if you remember, we are talking about that rubber band effect as well, where we can expand as well as contract, right? Do you have contraction possible here in private?
No.
Physically, no. Because let's say you have bought 1,000 servers, and let's say you are using 500 of them. You bought 1,000 servers, but you're using 500 of them. Now, if you immediately need additional capacity from 500 to 1,000, you have that capacity ready and available. You can scale out. But when you're scaling down, you're not like throwing away those servers, right? You're just stopping using them, but you still have those servers, right? So although you have this, kind of the cloud fundamental where you have elasticity, but then you have a problem of having capacity that you've already paid for. So it is elastic, all right, but then you still have that idle capacity running around, right? So there is two problems here. For example, like I said, there is a top end and a bottom end problem here. Okay, the top end is that, for example, let's say your requirement was 500 servers and you have bought 1,000 servers. Okay, now you are limited to this band. You are limited to 0 to 1,000. Okay, and you have already paid for the 1,000 servers, but you're using only 500. So there is a problem in utilization, where you have paid more for than what you're utilizing, And also there is a problem in scaling, where let's say your scale requirement have hit 1000. Let's say you had 500 and now you're starting to use all 1000 servers, but now you need, let's say, an additional 50 servers. Are you only going to go buy additional 50 servers? Definitely not. You're going to go buy an additional 100 or 200, right? So again, you have to spend again more money. So there is a problem in both top end and bottom end over here in terms of both utilization and scalability. Any questions?
Yeah. So again, in my mind, I'm stuck at like making use of private cloud with or from AWS or Azure, right? It is possible. If it is possible, then majority of these things could be taken care of, right? Like elasticity and stuff like that.
So when I mentioned about the private cloud inside a public cloud, I was just mentioning a private environment within a public cloud. All right. Because when you are defining what a private cloud is, you are basically talking about setting up your own servers and things like that. Now, when you go inside the public cloud and when you create a private environment, you are not paying for those servers upfront, right? You're just using what was already there just to create a private environment. Okay. So that is technically not a private cloud, but there's no other definition to call it. You kind of call it private cloud because it is a cloud and it is private. But that's not what we are defining here as a private cloud. Here, private cloud, pure definition means that you are spending your money, you are buying those servers, you are creating it for your own use and you're running it, right?
Understood. That helps. Yeah.
Okay. I'm going to ask a question here. I'm sorry, something, Amit?
Yeah, no, the one question. So basically here we are just not considering the hardware as part of the problem, right? Besides hardware, we have the services also, right? For example, like when you're having the virtualization stack or anything like that. So how you're leveraging it or how much you're paying for that too would make a factor here, right?
Yeah, so that's also part of my next question. But anyways, that also kind of falls into CapEx because remember, if you're, for example, going and doing VMware for all of these instances, right? You still have to pay for VMware licenses and those are upfront. It's not like pay per use, right? Microsoft database licenses or Windows licenses, all of these are kind of upfront costs, which again add to your CapEx, right? There's no really operational model in all of these licenses. But there is something else that's a disadvantage over here, which is coming back to that question of resources that you all mentioned, which is human resources or people that are running these environments. But I will come back to this in a second because I want to ask another question here. Now, I'll ask a question here. Now, there is a word which I do not want to hear. Please don't say that word. Say anything else, but don't say that word. All right. The question is, what is the advantage of having a private cloud?
Faisal, I shared my scenario with you. Like I work for a bank and the data security was the major concern. And that's why my bank, where I work, like they have dedicated private cloud and they are mixing it with their non-essential applications with the public cloud on Azure.
You said the word.
Oops, I'm sorry.
So the question of what is the advantage of private cloud? The answer is not security. Okay. Security, I'll tell you in a second, but before I go there, anyone else, any other opinion on what is an advantage of private cloud? Did someone else say security as well?
No, I would say it's intellectual property, right? Example, if you're running your organization, you can have your core operations and then the other example for the banks. I don't think you want to run your core banking on top of the public cloud. It should be in the private. Example,
my question is why not?
No, if you imagine from the government to government something happen, if tomorrow they say I no longer give you the service, then how do we going to run the business?
Okay, so there is one word that you're talking about. I will come to that word. Just remind me if I miss it. But this is not about security. That much I can confirm is that there is no advantage about security in a private cloud. Let me explain. So when you talk about the concept of security, someone's mic on, Rajneesh? Yeah, thank you. So when you talk about security is not, someone's mic open. All right, security is not a function of just one thing. Okay, security is not one thing. Security is a function of many things in your organization. Security is a function of the software that you're using for securing your networks. Security is a function of the firewalls, the physical firewalls that you have in your network. Security is a function of the people that are managing your security, on how good they are in terms of managing your security. Also, security is how much you're actually spending on it in order to make it better and things like that. Security is not a single point. Security is a combination of a lot of things. Now, one thing I'd like to say here is that we talked before about resources or human resources that are managing your environment. Let's say you have a team of 25 to 30 people that are managing your data center. Your total security is dependent on the ability of these 30 people, 25 or 30 people, to manage your security. All right. If they are not experts and if they don't know everything, then you are not secure. Vis-a-vis, when you talk about the public cloud like AWS or Azure or anybody, they have hundreds, if not thousands of people that are constantly looking at security threats, that are constantly monitoring these things, that are looking at all of these services. So do you think a few small team managing security is better than maybe 1,000 people managing security or more? Would you agree or not agree on that? This is just one point.
Oh,
No.
just for discussion, right? I can run them in the air gap, right? I don't want the internet. Then I can block. Still, I have a
We'll
choice.
talk about that. We'll talk about it. We are talking about how you're securing your data. That's another question. But I'm talking about people who are managing your resources or managing your data, right? You might have heard about the recent Twitter attack, right? Where a lot of people's accounts were hacked. That happened because the people who are managing, people who had tools to do that, they got, they got phished. So for example, if you are an admin and someone phished you and you end up giving credentials, all of the control the admin has, now that other person also has, the hacker also has, right? So people are an issue when it comes to managing resources. If you only have a small team, that's going to be an issue. The second part here, when you're talking about human resources and money that you're spending on your security, when you're talking about security, the more you spend in better software that can manage your security, the better, right? Now, as an organization, you might not have the highest security budgets in the world. All right, you might still be limited on how much you can spend on your security. All right, so you might not have the latest and greatest software. When you talk about the public cloud, how the public cloud works is they are able to split their costs across all of the people that are using the public cloud. So for example, AWS can give you the best software, best security software at a lower price because they're able to split that price across hundreds of customers, right? But for you as an entity internally in your organization, you might not have the highest security budget. So you might go for one level down or two level down, which you think is sufficient enough for your organization. But that again exposes you to additional risk. Okay. Coming back to the first point of number of people that are managing your resources. If you know, about a year or two ago, there was a vulnerability in one of the Intel processors which had a firmware vulnerability, right? Now, public cloud providers had so many people that were looking at this issue that they were able to patch their entire ecosystem 10 times faster than any private player was able to do it, because of the fact that by the time private players got to know about it and their guys actually implemented it, the public cloud people already knew about it, they already implemented it, and the fix was done, right? So you get some scale in speed and scale in security as well. Any questions here or any disagreements?
No, you're right. That makes sense.
See, if you came and told me about 5 years ago that the private cloud was more secure than the public cloud, maybe we would have agreed, right? But over the last few years, the things have changed. Let me give you another example. when you handle private data and when you're talking about regulations, you have things like HIPAA compliance, right? And many other compliances that come in depending on which sector you're working in. Okay. Now, you might know by now that if you need to achieve those compliances, you have to spend hundreds of thousands of dollars. Okay. And it takes a very long time for you to actually achieve those levels of certification. Now, when you talk about the public players, they have already achieved all of this. So when you're using it, you are getting the like a subcontractor benefit where they already have the certificates like HIPAA compliance and FedRAMP compliance and all of that. And you're kind of just getting that by default. So when you run your service over there, you are already meeting those standards, right? And those security standards.
So one question I have here, Faisal, say for example, all right, consider just for discussion's sake, like you have Apple on one side and Samsung on the other side.
Mm-hmm.
Can they both be a customer of AWS on public cloud?
Yes, they can, because when you come onto the public cloud, they don't know, like Apple wouldn't know that Samsung is on the same cloud as they are, and Samsung wouldn't know that Apple is
I
on.
think, is it not a requirement for a cloud provider to share their customers if they are from the same industry?
No, so they will share their customers to show off how many customers that they have, but they're not going to share it because, like, if Apple goes and asks AWS, show me your entire customer list, they're not going to show it, right?
No, Apple will ask like, do you have any of my competitors as your customer?
See, most of this information when it comes to major companies is already public. Like they already disclose the major players who are already in there, right?
So
now, not only that, if you just go to a website, let's say, for example, you go to Samsung website, and if you just look at the loading metrics of those websites, you can easily figure out whether they are already on AWS or not. All right, because certain links actually point to services inside AWS, right?
So my question is from the different angle, like from Apple and Samsung side, what will be their apprehensions, if at all there will be any?
So that is what the public cloud providers are trying to say to these people, is the fact that they have separation within their clouds, they have security protocols that they have set up. They are trying to convince these players that it is as good as running your own private cloud, because what happens is I told you about the software, the different kinds of softwares you can use to control, right? Maybe as a private player, you might not have that capacity to buy all of that software. AWS has tried and is still trying to convince a lot of people that they have enough security tools on AWS that it can be as good as a private environment, right? As a private cloud, right? Because there are things like your security groups, your firewalls, your IAM, and all of this, which will basically control it in such a way that no matter who else is on AWS, you have secured it in that way. For example, there are like encryption keys, right? You can encrypt data on AWS and you have the keys. Even AWS does not have it. So even AWS cannot read your data, right? Because you have encrypted it with your keys. So in that way, they try to allay a lot of apprehensions and fears in that way.
So then I can say that in the end, like again, the key selling point is security, right?
Today, cloud, yes. Because over the years, public cloud providers have been trying to fight that perception that public cloud is not secure. So they have built up a lot of resources and a lot of good reasons in terms of better security on the public cloud to move to the public cloud. But like we mentioned, that is not the only reason. There is, of course, OpEx, but security is today a major reason why you would probably want to move to the public cloud, right? Because as a small player, you will never be able to achieve the scale of security on AWS or Azure, right? Yes. Think of it. If you're starting off today as a data center and trying to run your own private cloud, unless you have a very deep pocket, you will never be able to achieve that level of security within your private data centers, right?
Right. Okay.
Faisal, I think I can assure you, like I have been working with the banking environment for some time, and I have seen your profile. You have also been working in the same for some time, right? Mm-hmm. But on my side, like I haven't seen our management convinced with moving their data to cloud, where they have all their real banking data. like non-essential applications like SharePoint and all that things, they are already there with like different vendors, but none of their critical data is still in public cloud. Everything is in their private cloud. Like this is the mindset coming from the management at this point, as per we speak today.
Right. So you're absolutely right. And see, as a managed cloud services company, one of the major challenges that we ourselves face is actually convincing these management folks that public cloud is better, right? And I will tell you why this challenge comes up often is because of the fact that people who are already CTOs today are people who have already built up their own clouds, who basically are like, this is my baby, I'm not going to let it go kind of a mindset. All right. And some of them have unreasonable reasons why they are still sticking to the private cloud, but there are good reasons why you should stick, which I will explain in a second. There are good reasons why you should stick to a private cloud, but a lot of those reasons are unfounded. For example, like I said, if you were claiming that you have better security on private cloud, then that's not necessarily true. All right. But if you have good reasons, for example, talking about data sovereignty, okay, data sovereignty is where this is the only advantage of private cloud as of today, the way I see it. Data sovereignty is where you are not only owning the data, but you also have the data with you. Okay. For example, let's say you put your data in the public cloud. Okay. Of course, you're not making it public. Your data is still private, but you have put it in the public cloud. Now you are still the owner of that data. Okay. But you don't have that data with you. So then the question comes, which someone else asked here, is what happens tomorrow if that company says that, okay, this government is no longer allowing us to do this, we have to shut you out, and that's it. You lose all of your data in some cases, right? And today, for example, we've already seen like TikTok bans and all of that, where out of the blue, you can get completely kicked out. So in those kind of scenarios, having a private cloud is definitely advantageous, where you are not only the data owner, but you actually have the data with you. You have data sovereignty, right? But this can be easily overcome by just having a backup of your data with you out of the public cloud. If you're going to go to the public cloud, you are never going to go full public cloud. And if you're going to go with private, you're never going to go full private. This is exactly why we have another model called hybrid model. Okay. We'll discuss that in a second. But does that answer your question on why a lot of people are still kind of held back on not wanting to move to the public cloud? Because a lot of them have that mindset that, you know, we have taken so many years in building up this infrastructure, we're not going to let this go kind of a scenario.
That's the reality. That's reality. I agree. 100% agree with you.
Right.
But then, Faisal, quick question, Amit here. So, for example, like healthcare and like other departments, right? So there are certain areas where they're still struggling in the private cloud, right, to get those kind of security assurance in place.
As far as I know, they literally have almost all of the certifications that are involved in the health sector. And also, the AWS is the only organization today that provides a dedicated government cloud. So there is something called GovCloud for AWS. There is 2 regions that they have in the US, which is actually certified for government only use, right? So the US government actually has services on AWS, which is running specifically in that GovCloud environment, which meets compliances like FedRAMP and all of that, where, you know, you have to have an environment that is absolutely secure to government standards. So they even do that, right? So I doubt, I'm not aware of any compliance that they don't have, unless there is something specifically, you know, I'd like to definitely take a look at that.
Yeah, no, I know like 2 years back, they had that HIPAA certification, but what I knew was they were not pushing on all the applications onto the cloud. They were saying that these are the set of applications that you can host in cloud, but not these ones.
Yeah. So when you talk about HIPAA certification and all of that, it has to be applicable on every model, right? because HIPAA certification requires you to have certain parameters that are met. So what happens is not all of the services that AWS provides is necessarily HIPAA certified. Okay, there are certain set of resources. So that is always a challenge of a company to make all their services fully certified with everything, right? But at the same time, you're trying to make your services highly scalable, highly agile, and all of that. And when you try to do that, it might sometimes conflict with certain standard requirements with these certifications. So yes, there are challenges there, but if you want today, if you want to be HIPAA, if you want to run a HIPAA certified application today, you can do that today on AWS. You don't need to go spend millions of dollars trying to get that.
Yeah, got it. Yeah.
Okay, this brings us to hybrid cloud. So what is a hybrid cloud?
Combination of two.
Very good answer. Did you just read that from the previous slide?
No, I did
Okay,
not, but now I see it.
You're not wrong, but help me with something more. Give me something more.
Yeah, mix of like so you have some of your applications on private cloud and some applications on public cloud. Just a mix of both, right? So that's what we can think of.
Right. So think of it like this. Initially, the conversation around cloud was, should we use private or should we use public cloud? Okay, and there was obviously a lot of debate, and public cloud won that debate, and a lot of people moved their resources to the public cloud. Okay, but then there were a lot of organizations that were holding back, saying that we are not ready to move to the public cloud because we have certain security things, we have our data, we don't want to put it on the public cloud, etc., etc. All right. Now, this is where the hybrid cloud comes into the picture, where you have the opportunity to decide what part of your environment is going to be on the public cloud, right? So for example, let's say you have, hold on a second. So let's say you have your own data center, which is called your on-premises, and then you have the public cloud. Okay. What you will do is you will have a set of resources that are there inside your on-prem. Okay. And at the same time, you will try running something on the public cloud as well. Now, in order for this to be truly called a hybrid cloud, these services have to work in combination. Okay. This is not going to be a case where you're running 5 services here and unrelated 10 services here. All right. That's not a hybrid cloud. I mean, you can say that you're using both public and private, but that's not a hybrid model per se. Because if you want to call something truly hybrid, think of it like this, where, for example, your database servers, your DB servers might be on-prem, and your web servers might be on the public cloud. My pen is totally bad today. Sorry about that. So you will have your DB servers, which actually hold your database data inside your on-prem, and you will have the web servers in the public cloud. Now, these both are working in conjunction, right? So when somebody accesses your web server via the public cloud, they are also pulling data from your database in the private inside your on-prem. This is what is essentially you would call a hybrid environment. Okay. Now, you obviously don't want to do this model per se, where you're putting your DB somewhere else and your web somewhere else, because that will introduce a lot of latency and issues. But it should be something like this, where maybe your email servers are in the public cloud and rest of your application is in the private cloud, but they are all working together. Any questions?
I would say it's more like a big data solution, like where you have the data warehousing and on-prem and the Elasticsearch services running on the public cloud.
I'm not sure if you would want to do that, because then there will a lot of data has to flow between the two environments, right? Because when the Elasticsearch is trying to pull up data, it has to do a ton of processing, and there's going to be a lot of data movement between these, right? But yeah, you could ideally have your data lake within your on-prem, and then have some processing servers on the public cloud if you wish to. But the idea here is that they should work together, not separately.
So we have real-time scenario of this one. We use Informatica integration services in cloud, and then we have our Oracle databases in our private cloud. So that's a exact hybrid cloud
You're
scenario.
saying that your company is doing this right now. Is that what you're saying?
Exactly. That's right.
Right,
Yeah.
right.
Yeah, that's right. Yeah.
True. So here you can basically get the advantages of the private cloud, which is your data sovereignty, where you keep your actual data with you, but then you are using all of the advantages of the public cloud, which, you know, scalability, on demand, and all of that stuff. But at the same time, you have some data sovereignty. Any questions? Okay. The three leading cloud providers, as you know today, AWS.
One question, Fazal,
Yeah, sure.
really quick. So do you have an example of a banking company who is like kind of 100% on cloud?
I believe that is, hold on, I'll just tell you, AWS already has that.
I think Capital One is one.
Yeah.
has
Capital One,
got-
Capital One, correct. That's what I was looking for. Capital One is completely on AWS. They have their entire environment on AWS.
All customer data, customer financials, everything on cloud, right?
That is what they claim, but you know,
Okay.
we can only believe what they say.
Okay, thanks.
If you want, you can always go ahead and look up by industry on their website, which should tell you. So all of these providers, and Capital One is one of them. So there is DBS, National Bank of
DBS.
Australia. So I don't think
Okay.
all of them are fully on, but I do know that Capital One is completely fully on AWS.
Okay.
All right. Okay, so we've had an interesting conversation with all of this, which means we have exceeded our time very much. We still haven't touched about intro to AWS. Okay, so we only have another 5 minutes. So probably let me just quickly wrap up this part, and maybe we'll come back to intro on AWS tomorrow. But let's see. Are you guys willing to stick around for another 15 minutes?
Yes.
Yes.
Okay. All right.
I can do.
All right. Let me just quickly go through this part. Leading cloud providers, AWS, Azure, and Google, as we already know. The reason I brought this up is because to tell you how they grew up in the sense. So AWS always was initially an IaaS provider to start off, right? So they didn't have a lot of PaaS and SaaS services when they began. They just had like EC2, S3, and all of this, which was more core services where you were running whatever you wanted on top of AWS. And AWS always has been known for being the best IaaS provider, and they still are. Azure started off mostly with PaaS services because of the fact that they already had a lot of partnerships around the world through Windows anyways with a lot of organizations, and it was quite easy for them to provide like SQL as a service, Active Directory as a service, etc. on top of Azure, right? So they were very good at giving platform as a service. Guess what Google has been good at?
Gmail.
SaaS. Huh?
Yeah, Gmail.
Right.
Yeah,
I mean
yes,
SaaS. So Gmail
Yeah.
was SaaS. Then you have the entire of Google has a Office suite that is there. So they have that. Then they have a lot of app services. For example, the backend of your Android apps, everything run on their SaaS platforms and everything like that. So they have always been good at SaaS. Over the years, AWS has been pushing a lot towards PaaS. And in the last, I would say 1 or 2 years, they have made great strides in SaaS as well. So PaaS and SaaS is something that AWS has been pushing over the last few years. Azure has been pushing more on IaaS, right? Azure still not that great on SaaS. They do have a few services, but they're not that well known for SaaS services. Google has been, sorry, something adding?
Yeah, Office 365, right? Microsoft, is that not
So
on
that is
Azure?
just one thing, right? There's nothing else that they have. I mean,
Okay.
that's the one
That's
core
a big
product
thing,
that they
but
have. Yes, that's definitely, and in fact, they have been counting it under their cloud revenue, although that's not really cloud per se. That is just like another email service, right?
okay.
So whenever Azure is actually declaring their total cloud revenues for Azure, they're actually counting Microsoft Office as well. okay, which I don't think is fair, but then, it's how business works. Anyways, so Google has also been pushing on IaaS, and they have got quite a few good large size organizations that have moved to their IaaS platforms. Google has some PaaS platforms for data analytics because they have been real pioneers in big data query like BigQuery and all of that. So they have a lot of tools in the PaaS space as well. But if you want to call it a fully 360 functional provider, you definitely have to go with IaaS because they kind of have everything that you can think of. And remember, when we are talking about SaaS on AWS, the basic idea with AWS giving you a SaaS is telling you, don't do it yourself, we will do it for you. Okay, that is their motto for almost every service that they release nowadays, because it's not really, I wouldn't call it innovation, but that's basically what you're getting. A lot of services that they're releasing are something which you're already doing. All right, it's not something new, but they're basically telling you, okay, let me take this work off you, you don't worry about it, we will do it for you. Okay, that's kind of the scenario that you have with AWS nowadays. Okay, let's quickly move to the history and introduction of AWS. So AWS started back in 2006. Anybody know which was the first service that AWS launched?
Must be EC2
Not EC2.
or S3.
Not S3.
Don't know.
There's the service called SQS, or Simple Queuing Service. That was the first thing that they actually released in 2006. So SQS was the first service, and AWS was created extensively out of the knowledge of building Amazon.com. So Amazon.com, it's been existing since several years. And when Amazon.com was trying to expand globally, initially they were just in the US, right? Then they had their European sites, they had their Asian sites and things like that. So when they started expanding globally, they also faced the same issues that any company would face in terms of scaling out their backend IT infrastructure, right? So they put in a philosophy and they built their backend infrastructure in such a robust way. That's why if you go to Amazon.com today, and in any scenario, whether it is a sale day or whatever it is, you never really see it failing, right? Because that's the way they have built their infrastructure. Now, when they build their infrastructure for Amazon.com, they realize that they have built something so good that they can actually offer the same thing to other people. That's where kind of AWS was born. So AWS is basically the backend infrastructure for Amazon.com. I mean, you're not getting the same servers that Amazon.com is running on, but the ideology is the same. The way they have built the backend infrastructure for Amazon.com, that is the same kind of reliability and operational performance that you're going to get when you use AWS. So think of it like your site is going to be running on the same level of resources, availability, performance, everything that a multi-billion-dollar site like Amazon.com is running on. Okay, so that's the level of service you get. They've always been an innovation, customer-focused company, which basically means that if you want some new service on AWS today, it's really not that hard to get it done. You have account managers which you constantly are in touch with, and if you talk to them, and if they actually find out that there's a real good need for this, they will bring out that service. In fact, a lot of these additional services that AWS has built over the last 5 years has been purely based on feedback from their own customers in terms of they're telling them that they want this service, right? So they're a very innovation customer focused company. I'll come back to that in a second. I'll show you that what I mean by that. This last line, this is something that they confirmed about, I think about 3 to 4 years ago. Okay, so this number is definitely higher today, but this is something they said 3 to 4 years ago, where they said every single day they're adding capacity that is equal to one Fortune 500 company. What I mean by that is, you know what a Fortune 500 company is, right? One of the top 500 companies listed in the stock exchange in the US. So how many servers do you think a Fortune 500 company has? A rough estimate. Anybody? a single Fortune 500 company, how many servers do you think they have?
It should be more than 10,000 to 20,000 servers.
I would say the minimum 10,000, right?
Yeah.
I mean, it's a Fortune 500 company. There are millions of customers around the world, right? So think of it like that. AWS is adding that capacity that a Fortune 500 company needs every single day into the AWS network, which means they can support one new Fortune 500 company every single day on AWS. This is why you never really see any resource issues or out of not having enough resources to run on AWS. There are some exceptions where AWS maybe just recently opened up a new region and they're offering you services over there. In those cases, yes, sometimes you might see that there's not enough resources, but once that is fully up and running in a few months' time, you will never really face a constraint issue. I don't know if you noticed, but last year, Azure hit a roadblock because of this issue. Their largest region in the world, which was in US East region, they could not add any more capacity. Azure customers were getting messages saying that there's not enough resources to run. Obviously, someone did not do their planning properly within the organization. It shouldn't have happened anyways, but that also shows how different AWS is, because they don't wait to get to that point where the capacity ends. They just keep adding continuously, that there is a never ending resource availability. Any questions? All right. If someone asks me what is AWS, I would basically say AWS is a cloud infrastructure and services platform that helps users build highly scalable cloud backends to deliver applications and services in a highly available and on-demand manner. So this is my definition of AWS, and you don't need to remember this, and you don't need to even copy paste this anywhere else. This is basically what AWS does. In a single word, they do everything. Okay, there's nothing they really can't do when you talk about IT infrastructure or services that they're offering. But to truly know how AWS works, remember I told you that they work at an exceedingly rapid pace of innovation. They're a very innovative company. Now, these bars that you see here are the number of newly launched services and features every single year. Okay, this is not 48 plus 82 is 159 plus 159 is, no, that's not the case. This is single numbers for every single year. So for example, I'm not 100% sure about this number because that's not officially come out yet. But if you just consider 2018, they released over 1,500 features and services for the whole year. How many is that per day? I think that comes to what, 3 or 4 new feature and service per day, right? So you can imagine, if you do not look at AWS every day, and you did not look at the new services on AWS or new features on AWS every day, you ignored it for a week. When you come back, there is at least like 30 or 40 new features that are there on AWS. So it's in fact very hard to keep up with everything that's happening on AWS. But remember, these are not all new services. They're also feature improvements, right? For example, something was done in a different way before, and now something else is done in a different way. And believe me, by the time we are done with this training, there would have been some new services and features that are launched. Please don't blame me if I don't teach you those, because they were never there to begin with. All right. So by the end of this, you might see something new, and don't be surprised if you see so. Any questions so far?
So Faisal, like out of these 2,000, like how many of services we use on the regular basis, like the regular core infrastructure services on our daily basis? Maybe
I believe
like 150, something like that.
I believe the total number of core services that they have as of today is 175. Out of that, you probably would ideally not be using more than 80 at the max. Okay. Because a lot of these services are spread across different industries. For example, AI, ML, for example, analytics and all of that. So as an organization, you might not need all of those features, right? So you're not necessarily going to use all of those tools.
Right. And when we go for exams, then do we need to know about all these services, or need to have some idea about these?
No. So the thing is that the exam is always a little backdated, in the sense that if a new feature is released, that does not show up in the exam at least till about 1 year later.
Okay,
all right.
Sure.
At the minimum 6 to 7 months. It's not going to show up earlier than that, because they want people to get comfortable and use that service, and only after that is when they really start asking questions. In fact, the C02, which is the 2020 curriculum, okay, this is actually adding new content into the exam, which was released almost 2 years ago. Those services that were released 2 years ago didn't actually come in the previous exam. It's now starting to come up. So you don't need to worry about having to learn everything immediately, but eventually, maybe in a year's time or so, you'll start seeing them in the exams.
Sure, great, thank you.
Okay, this is again because of that rapid pace of innovation that I've said. They've got over 4,000 plus features and services that are there. For example, they have Poly for voice, they have Athena for analytics, they have recognition for image recognition, Greengrass for IoT, step functions, Lex for the backend of Alexa, QuickSight for visualization. Like literally anything and everything that you want to do in terms of IT infrastructure and applications, they have all of that. Okay, now again, you don't need to worry about what each one of these are. We'll learn most of them, and some of them you're never really going to even be touching. Now, what does this all mean? This means that AWS has always been the leader in IaaS, and I believe this is the 9th year in a row that they have been named by Gartner, which is a company that does the research for the all of the companies around the world, right? So they have put AWS as the best performer in IaaS, or the leader in IaaS space, for the 9th consecutive year. All right. I believe 2018 was 8th or 9th, I don't remember, but they have been doing it consistently for the last several years, being IaaS. Now, they are not a leader in SaaS or PaaS. Just keep that in mind. There are other companies that are better in that, but IaaS, definitely definitely Amazon is leading. So if you talk about job opportunities and things like that, you would definitely, by nature, because they are leading and because they have more customers, they will definitely need more people and hence more openings. All right. I'm not saying that neither Microsoft or Google doesn't have enough job opportunities. There are, but comparatively, AWS will definitely have more opportunities in terms of work profiles. Okay, and one of the reasons that they're leading is because of their complete end-to-end platform. Remember, I told you they literally have everything that is available. Now, this particular screen that you're looking at, probably, I'm not sure if you're able to read everything on your screen because there's just too much information here. 3 years ago, when I created, or when AWS actually provided this chart, it wasn't this big. All right, very few services. And the year after that, it's more services, more services. Now, this is actually from mid 2019, I believe. After this, they have released another 50 odd services. All right, so nowadays they can't put all of it in a single chart, so they're kind of breaking up into multiple slides. All right, but the idea here is that if you look at this, they have end-to-end IT infrastructure, which is starting from your core infrastructure, which is all of the different regions that they have their data centers in. Then you have the core services like your compute, your storage, your networking, your databases, your global networks. You have security modules, which will allow you to control the access into your environments. You can control who all those people are. You can control your keys that are used for encryption. Then you have a ton of management tools that will allow you to manage all of this, track all of these changes, etc. Then if you look at this entire section in the middle here, this is what I generally call either the SaaS or PaaS section. So all of these are SaaS PaaS applications. So for example, they even provide VDIs. So if you want a virtual desktop, which is like a remote desktop, you can get that on AWS. If you want your email set up, you can get that on AWS. Let's say you want to do AI related stuff and image recognition. There is a service available on AWS as a SaaS. All right. You want to do IoT, connected devices, you can do that. You want to do a lot of development on AWS and have things like your API environments and things like that, you have that. You, again, DevOps, a ton of services on DevOps. You want to do analytics, data warehousing, Elasticsearch, Hadoop, literally like anything that you would need is there. All right. And if you want to migrate your environment to AWS, they provide you a ton of tools to do that migration, making migrating from your on-premises into AWS cloud so much more simpler. All right. And to support all of that, they obviously have some support as well. Now, one thing that you have to remember is support is not free. Okay, no free support with AWS. You have to pay for support. With the free account, you only get billing support. So if something wrong with your billing, you can talk about it, but there's no technical support. You have to pay for technical support. So there are different levels. There is like a developer level. There is a I think mid-organization level, and there's an enterprise level. All right. And when you talk about enterprise level, they're going to take like 10% of your total bill. So if you have a $1 million bill with AWS, you're probably going to pay $100,000 in support fees. All right. So just keep that in mind. And that's probably the reason why a lot of people are doing AWS training, because those companies don't want to give their support to AWS and they want it to manage internally. All right. So support is not free on AWS. Just keep that in mind. And you have this one major component here, which is marketplace. This is why AWS has went ahead and captured a lot of the market in the recent past. Think of it like this. Marketplace is something where third-party providers come and offer their solutions on top of AWS. For example, let's say you want to set up a TIBCO platform on AWS. All right. You can just come to the marketplace, subscribe for that TIBCO platform, click on a single button. That entire platform is deployed within a few minutes into AWS. And then you can just use it just like that, right? Let's say you want a complete Active Directory environment within AWS. Microsoft offers you that solution. Just go in there, go to the marketplace, subscribe for that, and immediately it's deployed. Let's say you want some other analytics solution. You want, let's say, a kind of RAID storage solution that is available. Just go to the marketplace, buy that subscription, and immediately it will be deployed. Of course, you have to pay additional for the subscription, or you have the option of not going to the marketplace and doing everything else on your own by using these underlying core services on AWS, by building your own stuff on top of AWS. Is this clear? Any questions here?
No questions.
So what we'll do today is we will start off from the very basics over here, which is, if you look on the left-hand side, you have the infrastructure section, which has all of the regions, availability zones, and point of presence. All right. So let's start here and first understand the infrastructure setup of AWS. And then post that, we'll go into the core services and understand things like EC2 compute, and then going forward with storage and all of that. All right, so let's talk about the core global infrastructure services for AWS. So this comprises of three main things, which is regions, availability zones, and point of presence. This will define how, or rather where AWS has their locations, where their data centers are, how they are interconnected, and how you can achieve availability by making use of availability zones. All right, the first things first, let's talk about the regions. So regions are basically where AWS has a presence, or AWS has a data center, at least one data center, right? Now, there are a total of 24 regions that they have as of today, and there are 3 more that are in the pipeline that will come out soon. Now, one thing to understand is that it does not mean that you have to be in one of these regions to access that region. Okay, that's not the case. You can access any region from anywhere in the world. And also, it does not mean that if you are in a country that does not have a region, that you cannot access AWS, nothing like that. Anybody can access AWS from anywhere, and anybody can use any of these regions. So even if, for example, you are in the US and you have customers in India and you want to set up the servers, you can probably do that on the in the Mumbai location. Now, how you'll determine which regions you will need will completely depend on your actual requirement. So, for example, if you have a requirement where your customers are predominantly just US-based customers, right? So then you probably want to select one of these regions that are available in the US. The oldest region, or the very first region that AWS had started, was the North Virginia region. And that has the largest capacity as of today. In fact, many of the other providers also had actually started out in North Virginia, like Azure and all of that. So these are the regions. You can use any of these regions. How you would use them, or sorry, rather, which one you would use will depend upon where your customers are. Sometimes when you have global customer base, you would want to still have at least one region. I mean, you can have multiple regions and run all of them simultaneously, but remember that will increase your cost. So if you remember yesterday, we talked about the load balanced cloud and high availability cloud, where we have the cloud environment across multiple locations, right? So picture that on this, right? So, okay, before I go forward, any questions so far? All right, let's talk about edge locations. So apart from the regions, there is also something called edge locations, which AWS has. Now, remember I told you the scenario where if you have customers globally, how do you deal with that? Because you literally can't go and start your servers in every single region. I mean, nothing stops you from doing it, but then that would turn out to be a really expensive proposition, right? You don't want to do that. So that is where the edge locations come into the picture. Now, if we just go back for a second and we talk about what would happen if you did not make use of edge locations. So for example, let's say you are a US company and you set up some servers in North Virginia, all right? Or let's say you have predominantly customers who are US and you set up your environment in North Virginia. Now, all of the customers that are there in US, they can easily access that, right? No issues. All of them can easily access those environments anywhere they are in the US. There wouldn't be a speed issue or anything like that. But what about customers across the globe? Let's say there is customers in India. So when they try to access it, they're obviously going to experience much more delay or a latency, because literally they have to go across the world through the fiber channels that have been laid across the world. And then they will connect to your environment, and then they will see whatever they're seeing, whether it's a website or some other service that you're offering, right? Now, as you go further away, obviously this is going to become problematic. The latency is going to increase. So you need some other solution. I mean, the straightforward solution would be to say, okay, let me go ahead and start another environment in Mumbai, right? Where all of my Indian customers can access it. So you might have your customers in India accessing a particular environment in that region, right? You could do that, but this is not going to be manageable, because of the fact that then you literally have to start up in every single region, because you're trying to offer faster access to your customers. This is where the concept of edge locations come in. So think of edge locations as a caching location, like your cache, not CA, CH, sorry, not CASH. So we are talking about CACHE, cache, right? We're talking about stored data or cached data. So all of these edge locations, they are not a region. Okay, you can't actually start up servers inside an edge location, but the edge locations are predominantly just meant to act like a caching location for your customers. What that means is, let's say, for example, I started up in North Virginia, right? And like I mentioned, all of the customers in the US should be able to access it directly. But all of these edge locations, they basically try to take the data from the actual region and cache it. Okay, so they will cache it across all of these edge locations. And now if there is a customer in India, instead of he accessing your region directly in North Virginia, he will be redirected to the region that is closest to him, or he will be redirected to the edge location that will be closest to him, right? So when he tries to access something, he is going to get the data from the edge location and not from your actual region. Now, all of the edge locations are not always going to fully cache all of your information. It is going to be dependent on what is being accessed. So for example, let's say there is a file called abc.txt, all right, the main region that you have. Now, at this time, when you start off, none of the other edge locations have that file. But then let's say somebody in India requested that file once. The first time, obviously, it has to connect to the region to fetch the file. But once it connects first, at least once, it will basically cache this file in that edge location, so that the next time someone asks for it, it'll be fetched from that edge location. So this is the concept of edge location. This is basically your CDNs, right? Content delivery networks that you see across any provider. For example, there is Akamai, which is one of the largest CDN providers that are there. So think of this as an alternate to one of those providers. Now there are different layers for this edge location. There is just edge locations, there is regional edge locations, etc. We will talk about this when we discuss the actual service on AWS, which is called CloudFront, which is what these edge locations run on. Okay, so we'll discuss in detail how this actually works when we talk about that topic. But in general, did you understand what an edge location is? Any questions?
I got it. Thanks.
All right. Thanks, Vijay.
Faisal,
So,
if you can do like once more for me. Sorry, I missed that. The edge
Sorry,
location.
go ahead, Abhi.
my question is this edge location, this is just only for read or read write, both?
At this moment, this is for read, but there are certain write functions which you can do, which we will talk about when we talk about a specific service that is there, right? For example, when you use S3, you have the ability to use the edge location to write to S3 directly in the region, right? So we'll talk about that. But in general,
Okay.
when you talk about use of edge location for your customers, you're always talking about reading, not writing.
Okay,
Okay.
great. Thank you.
Yeah, Amit?
Okay. Oh, got it. No, that's what I was trying to understand.
same
The edge
question.
location, I didn't understand properly. So yeah, got the point now.
Okay, fair enough. All right, like I mentioned, we will talk about this in much more detail when we discuss the actual service that makes use of this edge location. Let's talk about AWS's global network that they have across the world. Now, unlike other providers, AWS has their own global network. You all know that you get internet through the cables that are laying across the seas, right? All of this internet is interconnected across the world using actually submarine cables that actually run under the oceans and the seas, right? So none of your internet as of today comes from satellite. So there is a physical wire that runs across the world. So this is one of that, and this is specifically for AWS. All of these lines that you're seeing here are basically their own cables that they have put across to connect all of these regions. Now, not all the regions are directly connected by a global cable, but AWS's own network will allow you to make sure that you are not using a generic provider network, because there are a lot of providers who have already laid these global cables or global networks already available for you. For example, when you're using your local internet provider, they're already using these kind of cables to go across the world to access any website that is anywhere. But the problem is that you don't have control over the quality of those cables and the connection, the stability of that, etc. But here, AWS has their own network, which means they can guarantee you some level of stability. They can guarantee you some level of lower latency. For example, if you are in India, and let's say you connected to one of the edge locations in India, when you're trying to access the other regions, you're kind of directly accessing them using AWS's own global network. So you don't have to if the connection doesn't go out into the normal internet per se, it stays within AWS's global network, which will give you much better connectivity and much lower latency. How they achieve this is they have laid redundant 100 gigabit Ethernet cables that are across the world. Now, to give you an actual visualization of this particular setup, if I click on this, I just bring this over here. So they have a portal which will kind of give you a better idea. So these are the cables that run across the world. So they have interconnectivity across the globe, almost across all of the regions that they have, and some of the edge locations as well. They are connected to these cables. Any questions? So these are all the regions and how they're all interconnected. Yeah, Rajneesh.
Yeah, so the cable connection is for each edge locations or only for the regions? For each edge locations, right? They all are connected.
So just think of it like this. Wherever they can directly connect their global network, they're connecting it. For example, if you see here, you can see that not only the Mumbai region is connected, but all of these other edge locations are also connected, right? But that might not be the case with all of the edge locations. For example, if you see one over here in China, you can see that one of this is not connected, right? So, but almost all, I believe all of the regions are definitely connected, but some of the edge locations might not be connected to it.
Okay.
Here you can see not, yeah, all of these edge locations are connected, right? All right, so let's talk about the concept of regions and availability zone. So we discussed what regions are briefly, which is basically a location or a presence where AWS has their data centers across the globe. Now, normally a region is within a city, but a region can actually be as large as hundreds of kilometers across, right? So it's not, if, for example, when I say Northeast Virginia, it's not, it might not specifically be the actual, one city within North Virginia, right? It might be spread across a larger area. But in generally, when you say a region's name, it is either linked to a city or the actual country name itself. So that's what a region is. Now, within a region, you have something called availability zones, or in short, you would call them AZs. So if you remember, we talked about achieving higher availability, right? If I just go back a second. We talked about achieving high availability, right? So if you see here, you can think of this one setup over here as what? What is this one whole setup here? Like this one cloud, what do you think this is?
One availability zone.
No, so this would be a region, right? This would be a region and this would be another region. Now within a region, you see that I have split up the systems, right? Like for load balancing. So in this, I can say that this is one AZ and this is another AZ or availability zone, all right? Because availability zones are basically data center clusters within within a region. So if I go, so if I were to take this whole setup as a region, okay, my AZs would be AZ1, AZ2, AZ3, and AZ4. Now inside each AZ, there will be data centers, right? One AZ might be one data center, one AZ might be more than one data center, all right? So when you launch your instances or when you launch your services into a particular AZ, you're actually launching that into data centers within the region, but a particular set of data centers. So when I launch my instances over here, and when I launch my instances in, say, let's say AZ2, any failure that is affecting this set of data centers is not going to affect this set of data centers because they are physically separated by some meaningful distance, and they also have redundant connectivity that is going in. For example, if there is one kind of telecom provider that is providing the service to AZ1, there might be another telecom provider that's providing the service to AZ2. There might be one kind of power provider that's giving power to AZ1, and there might be another provider that's giving power to AZ2. Because if you have the same providers and if one provider goes down, then both goes down, right? So the reason they try to do this is they try to allow you to maintain availability of your applications within the region by making sure that one failure does not affect the other set of systems that you have. So this is how you make use of availability zones within a region. The availability zones are physically separated zones which contain data centers in them. And there might be at least 2 AZs within a region. And the maximum there is so far is 6 AZs within a region. 6 AZs is in actually North Virginia, which is the oldest region. Newer regions, you would almost always have only around 2 AZs. And as the region becomes more mature, you will see like it becoming 3 AZ, 4 AZ, 5 AZ, etc. All right. Any questions here? So availability zones or AZs are clusters of data centers that are separated from each other by some meaningful distance so that a failure affecting one set of data centers will not affect the other set of data centers. And this is how you achieve availability, by making sure that you spread your load across multiple availability zones. Now, like I mentioned, there are at least 2 AZs per region. As an example over here, I have the North Virginia region and the Mumbai region. When Mumbai started off about 3 years ago, it only had 2 availability zones. And just recently, last year, they added 1 additional availability zone. So in North Virginia, you can see there are 6 availability zones. North Virginia basically is US East 1 is what the designation of North Virginia region is. And within that US East 1, you have AZ A, B, C, D, E, and F, right? So you would just say US East 1A, 1B, 1C, 1D, etc. Now, like I mentioned, each of the regions have availability zones within them. So how do you ensure that you have some level of high availability that you want to configure? Let's take one region, for example. Okay. Now, if I put my instances, or if I put my servers just in one availability zone, and let's say I did not have it over here and over here, can I call this high availability?
No.
No.
I cannot, because of the fact that this availability zone contains a few data centers, or it might, in some cases in newer regions, it might just be one data center, right? So if there is any failure in that data center, my application will completely go down. So what do? I go ahead and I create a copy of that across the other availability zone as well. And then obviously I'm going to put some kind of load balancer. I'm going to put some kind of load balance here so that when any load comes in, some of that load goes here and some of that load goes here, right? So that's how I split up the load to both my availability zones, by putting it on a load balancer that is kind of sitting in between them. The load balancer is not actually outside the availability zone. The load balancers are inside an availability zone, but we'll talk about how that works later on. Is this high availability? Yes. Is this high availability?
No,
No.
Fazal, because it is having only one load balancer.
The load balancer is actually a service and it's not a single product, right? So you don't need to worry about having multiple load balancers, which we will talk about in our session, I believe tomorrow, when we day after tomorrow, when we discuss load balancers. So don't worry about the load balancer, but in general, I only have 2 copies of my application, right? If I lose one copy, I am now down to a single point of failure, right? Because if I lose one of this, now I'm down to single point of failure. Now this is not high availability. Just as soon as you lose one copy, if you're down to just a single point of failure, you are not doing high availability. Yes, you have definitely higher availability than your previous setup, but this is not high availability. High availability, you would definitely want to put it at least across 3 different availability zones. And what do you think the regions will fail in any chance, by any chance?
Yes.
So we're talking about a region which has, for example, Northeast Virginia. It has 6 availability zones, and we know kind of by all of the talk that AWS has done that there are at least 2 to 3 data centers in each of these availability zones. So let's assume that 6 availability zones into 3 data centers is 18 data centers. Do you think an entire region can go down? Like 18 data centers across different locations in a region can go down?
No, no, I don't think so.
It could happen, right? Any natural calamities.
Yeah.
Actually, it has happened multiple times and it will happen in the future as well, right? So when AWS asks you to build your network, they always tell you plan for failure. All right. Don't just assume that just because you have put your systems across availability zones within a region that the region can't fail. The region can fail. The reason might be anything. The reason might be let's say a natural disaster that hit a particular location and everything is disconnected, or let's say there is some other issue with routing, network routing to that particular region within the state or something like that. Then it can definitely affect, right? And it has in the past and it will in the future. So if you want to be truly globally highly available, what do you think you should do?
Across multiple regions, you should set up your...
Right. So you will have multiple copies of your instances or your services across multiple regions and across multiple availability zones in multiple regions. All right. So in this case, because it is outside the regions, you can't use a load balancer. You would make use of a service called Route 53 or DNS. So in DNS, you will do load balancing where some of the load will go to one of these load balancers and some of that load will go to this load balancer, and internally it will split up the load internally, right? So this is how you will achieve higher availability globally. You will want to put your systems across multiple availability zones in multiple regions so that a particular region itself failing does not completely stop your application working. Any questions?
If I
Yes,
have a question. Sorry, go ahead.
Go ahead. Amit, go ahead.
So the quick question, so when we are talking about multiple region, wouldn't that, like, from a design perspective, it looks good. Usually that's what we do in a on-prem solution also, right? So when we know like critical servers, so you try to design in a way like you have it one in Arizona and one somewhere in like Texas or somewhere else, right? So that if Arizona has an outage, but we can bring up the servers in Texas. From the bandwidth and cost, would that also change, right? Because when you're selecting within the same region, the additional cost won't be more, right? Because the availability zones are on different data center, but then the cost wise, it should be less.
So when you talk about the cost, there are a few factors that you have to consider. The first factor is that services in different regions don't cost the same. Okay, so for example, the same EC2 in North Virginia is actually cheaper than the same EC2 in Mumbai. All right. So the resources themselves have a cost difference in each of the regions that are there. So they're not basically the same in that way. Now, when you talk about actually using all of them together, remember I told you yesterday when like you have one copy of your environment, it might cost you $10. If you have two copies of your environment, it is going to cost you close to double, right? And when you have 3-4 copies, it is obviously going to increase your cost. Now, the question that you should ask when you are doing this yourself or for your clients is that how much are they willing to pay for availability? All right. Let's say your client is saying that, yes, I want my site to be available on some degree, but I'm okay if there is a failure for like 30 minutes or something like that. Then you probably don't want to go multi-region, right? You can do that availability within the region across multiple availability zones. But let's say there's a global client that says, in no circumstance can at any cost that any of my service go down ever. Then in that case, you definitely have to put it across regions, across availability zones, and it is definitely going to cost you more because your client wants higher availability, right? If they are okay with not having higher availability, then you can cut down the cost and just have either 1 or 2 copies within the same region. So that's a choice that you get to make. But the idea is that you actually get to make that choice rather than being forced to, actually have it across multiple regions or not have it, right?
Got it. Okay.
Yep. Rajesh, did you have a question?
Yeah, Faisal. So within an availability zone, right? So is the application automatically replicated across the data centers that are available within an AZ?
Yeah, so that's one point that I wanted to mention. No, they're not automatically replicated. You have to place them in an availability zone when you set up. So for example, when you create an EC2 instance, it will ask you which availability zone do you want to launch that EC2 instance into, like which availability zone do you want to place that server into, right? So that is something that you decide. And also the fact that how many copies across how many regions, across how many availability zones, that is a choice that you make and you manually configure. They will be automatically launched for you, but you have to configure that and keep saying that I need some services in this region. So it does not mean that if you set something up in one AZ that it will automatically be replicated to the other AZ. No, you have to enable that, so to speak.
Okay, but within an AZ, let's say I launch it within one AZ, there will be multiple data centers within it, right? So is it kind of replicated within that?
So this will depend on what kind of service you're using. For example, when you're talking about an EC2, you're talking about a single system. So that is not replicated. But when you talk about a service like S3, which we will discuss later on, that is actually automatically replicated for you across 3 different availability zones, right? So you don't have to worry about, again, creating a backup of that particular S3 storage, right? So it depends on service to service. Some services are already by default available in the backend across AZs, replicated across AZs, so that you don't have to create a copy of it. But services like EC2 instances, they are not, because you're talking about a single VM, which cannot actually theoretically run across different locations at the same time.
Got it. Okay, thank you.
You're welcome. Any other questions? All right. I want to quickly wrap up this part about AWS by sharing the shared responsibility model that AWS has. The concept that AWS has always talked about is that there are 2 sides to the responsibility on the cloud. One is the responsibility of the cloud, and one is the responsibility in the cloud. And AWS has divided in such a way so that you understand when you launch something, what you have to take care of. AWS assures you that they will take care of the cloud itself. They will be responsible for the security of the cloud, which basically means all of the regions, availability zones, data centers, networking, the core underlying hardware, they will take care of it. But anything that you launch on top of that, for example, you launched a server, now you are in the cloud when you launch a server, and that service you have already launched inside the cloud. So now that becomes your responsibility. So you have to make sure that you take care of those things. For example, when you launch a server, let's say an EC2 instance, and let's say you selected a Linux operating system while you're launching it, taking care of the operating system security is your responsibility. If you don't patch or update your system, you cannot blame AWS when some unauthorized access happens on it because of some loophole or some vulnerability on your system because you didn't patch it. All right. So updating something like the operating system is your responsibility. AWS gives you complete control over the networking and firewall configurations. So if you leave all of your ports open and if you leave your entire network open, you can't blame AWS for any issues that happen outside of that because of that, right? So you only should open the ports that your applications require. You should not leave all of them open, etc. So that is under your responsibility. How those tools work in the backend, AWS already takes care of that. The actual hardware those tools run on, the actual software that tools use to run is actually AWS's responsibility, but configuring that is your responsibility. Also things like encryption. AWS offers you the option to set up encryption, right? AWS gives you all of the tools necessary, and those tools are maintained and set up by AWS, but at the same time, you have to configure it. You can't leave all of your data unencrypted on your disk and then blame AWS when someone reads that data that is they're not supposed to. All right. So it's your responsibility to make sure that everything that you launch inside the cloud, you take care of it. But everything that you are basically launching is already kind of in the backend taken care by AWS. Now, this will differ slightly from service to service. This primary model applies for IaaS services, right? So if you're launching something like an EC2 instance or things like that, then that is what this model will apply on. But we will see later on when we discuss the security section, we will see how when you start using something like a PaaS or a SaaS, this model slightly changes, right? So for example, for PaaS, AWS will kind of take care up till here, up till this section, okay? And for SaaS, obviously, they'll take care of the entire thing, except your actual data, which is your responsibility. Any questions? Let's stop here for today. Any questions let me just quickly run through whatever we have covered so far so that. Okay, so we talked about what the cloud is, and I've mentioned that cloud is basically a combination of 2 or more systems coming together to act like a single service is essentially the cloud. right? 2 or more systems. Now we talked about multiple systems working together, which is the cloud. When we talked about multiple groups of cloud systems working together, we learned that that's a load balance cloud. Then we learned that multiple systems across multiple locations, across multiple data centers is essentially a multi-region or high availability cloud. Then we looked at the different definitions of what a cloud is. Unless it meets all of these 5 characteristics, you cannot call that service a cloud service. Then we looked at the different models, the service models and the deployment models. Service models being IaaS, PaaS, and SaaS. And we talked about the deployment models being private, public, and hybrid. And we saw how they differ in terms of usage. We had a brief introduction into AWS and their entire pace of innovation and the services that they have and their entire service depth and breadth. We also talked about their entire core global infrastructure, which includes all of their regions, their availability zones, and their point of presence. Regions being different locations that AWS actually has a presence in, and the availability zones being isolated set of data centers within those regions, which are separated by a meaningful distance. Also their edge locations or their point of presence, which is basically making it faster for people to access the AWS data that you have. We also talked about the concept of having multi-AZ connectivity and how you would set up the concept of higher availability across all of the different availability zones and regions. We also briefly discussed the AWS shared responsibility model, where it defines what the customer has responsibility of, like responsibility in the cloud, and AWS taking responsibility of the cloud itself. Thank you for listening in, guys. Any questions before we wrap up the session?
Thank you so much. It was very, very informative and very interactive. I really appreciate that.
Thank you, Abid. Anybody else? Anything else?
No question. Thanks for the session.
All right, wonderful, guys. So thank you for connecting. Yep, thank you. And let's come back same time tomorrow. All right?
Bye. Sure.
Thank you, guys. Bye.
Thanks.
Thank you.
Thank you. Thank you.
Yeah, thank you. Bye.